There you go. So what is it today? 18th?
19th.
19th, 1 o'clock. We've got David Lochridge, Bonnie Carl, and Scott Griffith recording this. Okay, so first question. Give me some background. What brought this on? How long have you had some of these concerns?
Well, the concerns, basically, the second the dome came in and we got those dome cutoffs, okay? So the end segments. As soon as they came in, and I'm not just, sorry, I'll turn that on. Basically, as soon as they came in, and I wasn't the only one that was like, oh my God, okay? At that point, having no experience of carbon before, I thought, I'm going to do a bit of research on this, okay? Hence why I found out they do cut them off on most of the segments on, planes and boats and God knows what else. So on that, I did approach you and say, are we still getting this scanned, okay?
And it turns out you can't. We had looked at that, so keep going.
Okay. Do you want me to quote you?
Yeah, okay.
I'm not going to waste the money getting Boeing to inspect that piece of shit. I know it's rubbish, and what else was it? But at the end of the day, I've got to dive it. And I thought, wow, I was quite taken aback. We were down at the dock
I will
at the
say
time.
that I would not have said that without saying we have acoustic monitoring, which will tell me way before it fails. Because I would never say that without pointing out that we have acoustic monitoring. And and I don't think I said piece of shit, but Boeing can't scan, so it doesn't really matter. We've already looked into it. There is no NDT you do on 5-inch thick carbon fiber of that size.
So there's absolutely nobody on this planet. I mean, I thought that
not that we'll find the micro buckling spots and small delaminations. Yes. Gross delaminations, yeah, you can put it in a CAT scan and you can get data. We've looked at a lot of the stuff, but keep going.
Okay, so is the intention to best efforts get it scanned, or are we just not doing? What is the reason we're not trying to get it scanned?
Because the data we would get from a scan would not be meaningful.
Really?
Yeah. I mean, unless it was a gross delamination. So it has a gross delamination, and it is a piece of shit. We might see that in a scan. We will also see that with the acoustic monitoring. We've done enough testing with acoustic monitoring that we know we will see a bad. You want to see a bad hull? That sample we have, that 1/3 scale, clearly had a delamination a quarter of the way through. It went to 6,500 psi before it failed. And we knew at 4,500 psi that it was going to fail. So and no one from Boeing to any of the experts I've talked to has questioned that acoustic monitoring will not detect problems with your hull way before they happen.
Okay. Does it not alarm you seeing what we see? They're lying all over the place. We've got them in the
those are
order
scraps.
table.
Yeah, right.
We've got them everywhere, and they're from the 5-inch hull. Those are segments from that hull.
The only part of that segment that matters is the segment that is the part that was cut. The rest of it is scrap, and it's meant to be crap. That's why you cut it off. It's like judging a GM plant by what's in the dumpster.
Correct, but all that porosity, the voids, the delams, everything in there, the glue runs, it doesn't concern you?
Not at all, because carbon fiber is better in compression than tension. And that's what nobody understands. It's completely opposite of what everyone else says. Everyone says, oh, carbon fiber can't handle compression. They're full of shit, and I've proven them to be full of shit. If you want to see bad, you take a look at this 3rd scale model that we tested. Yep. That was poorly done. It had a massive delamination. It had porosity. It had voids. Yep. And it still worked. Oh, okay, Tony will join us. I didn't know you were going to join us. So that unit was, he did not heat it sufficiently. Okay. It was undersized. It was designed for, if you scale up that 3rd scale model, it scales up to a 4.2-inch, not a 5-inch hull. Okay. He didn't have thermocouples in it like we did with this one, so he could get the temperature. Okay. And as you scale up, the scale factor is in your favor because the fibers are smaller as a relationship to the diameter. So all 3 of those say that this will be better. And that one was, anyway, also, that one was good enough, but what's amazing is how poor it was. So it's a good news, bad news. The bad news is what the hell is Spencer doing creating such a product? And the good news is Spencer knows. That's why Fawcett went to him and why he's the only person who's made these hulls. Is carbon fiber in massive uniform compression is highly tolerant of voids, mistakes, and manufacturing defects, which is the opposite. I've talked to experts at DARPA, I've talked to experts at Boeing, I've talked to Spencer, I've talked to ATK, I've talked to General Dynamics. It's been an 8-year project. I know what the hell I'm talking about. Okay. So, keep going.
Well, what do you want to do? Do you want to go through the list?
No, but I mean, so you had that concern, and whatever I said, your interpretation was, I said it was a piece of shit and we're not going to test it.
Correct.
Okay. You've had, I'd like to go down all these things. But,
yeah, I think we should.
But part of it is I also want to know what led up to this and what's your goal with this document?
No, the goal for this document for me is the safety of anybody that goes in there, including you.
I understand.
Okay, that's it. I am just trying to do my job. I have approached Tony, you, and you, Scott, okay, on the matters, the O-ring, okay, the hull issues,
Correct.
okay.
Yep.
I've approached every, and I've just been dismissed.
No, I
every time.
told you the O-ring doesn't matter because it's a metal-to-metal seal under high pressure. You don't believe that.
Do you know why?
Right,
Because I've
part
had
of it.
first-hand experience of this.
Right.
I've had first-hand experience of a design that was the same as that with a double dovetail. Okay, it failed twice.
And
they
was
went
it-
back to the drawing board, and that
what
was
was
a
it?
pressure vessel. That was a project for the MOD, which I cannot discuss.
Okay.
Okay.
What was the shape of the
O-ring was
of the
exactly the
vehicle?
same.
No, not the O-ring. What was the shape
Flat
of the vehicle?
plate.
Flat plate. Was it a dome on one end?
I can't tell you.
Okay, so that doesn't help me.
It was a project for the MOD.
And when it failed, what was the
Yes.
failure mode?
What was the failure mode?
Yeah.
The O-ring.
Did it leak? Did it flood? What did it do? Did it
It
leak a
leaked.
lot, a little? Did it start to leak?
It started to leak.
At what pressure?
Was at 40 bar. 40 bar.
So quite shallow.
40 bar.
And so it started to leak.
Yep.
And then they came up and had to redesign.
Correct. No,
Okay.
we did it twice to verify the system.
What was the
Okay?
design intent?
Pardon?
What was the design intent?
A pressure vessel.
How deep do they want to go?
I can't talk about that.
Okay.
Okay.
Well-
Okay, so as a
That's
percentage-
signed an NDA
as a
for that,
percentage
so
was
no, I
what?
can't talk about
Okay.
it. Pardon?
As a percentage, it was what?
Okay, I think the thing with this meeting is I just want to verify everything on here. The reason being is I ask questions, I'm done, I'm dismissed, that's it, okay?
No, I
so
gave you my
instead
answer.
of me
You didn't like
being
my
here
answer.
getting the kangaroo court,
I don't dismiss you when I answer.
Tony,
No, I take issue with that.
okay, good.
No,
That's fine.
let's go back to the O-ring. I do take issue with that. We had a great conversation about the O-ring in the plunge hole.
Yep.
I answered all your questions.
Okay.
And what did I say?
At
For
first,
enlighten all of us.
do you think so? Do you think it'll fail? That's what you said to me. That's what you said on the shop
Do you think?
floor. Do
But
you
what did
think
I
so?
talk about the
And I
plunge hole?
said yes. The chances of that failing are high.
Okay, so keep going. What did we talk about?
Go for it.
No, enlighten us. I didn't dismiss you. What did I tell you that I did to verify that? I walked you through the design process to know that was okay.
No, you didn't.
Yes, I did.
When did you do that?
Absolutely did.
When?
What I told you
When
was
that? Months ago or?
no, when we were mounting the aft dome. What I told you was this. I said, look, I know as well as you do. I've never seen a plunge hole like that on a sealing surface like that. Do you remember this?
Oh, I do remember you saying that.
There you go.
That
So
was the
enlighten us.
day it came in.
Who did I
and
tell you I
looked
communicated
at it.
with?
You didn't say you
Yes, I did.
communicated with me.
Both TIFAB and Parker
Mhm.
agrees that plunge hole is appropriate.
Really?
Yes.
Okay.
And who did I call to know this? Their R&D engineers.
Okay.
So the design was done in concert
Okay.
with their R&D department.
Okay.
Now, if you can Google this on Google Images and go look for plunge holes on ceiling surfaces, and in fact, they're all over the place.
Okay.
But we did talk about this, and I said, look, I've never seen it in either. And then I commented, I said, if it's going to leak, we're going to know. It's not a catastrophic failure, but I said, we're going to know. And then I got to fix it, which is why I put the O-ring groove on the forward dome, and I didn't put it on the segment 1. I can ship that out and get it reworked. That is what we talked about, and I did not dismiss you.
Okay. So let's.
Can I ask, do you have that documentation from the people that you talked to saying that it's an appropriate application?
No, it's over the phone.
Yeah, he has your phone long.
You don't. I don't. They're not certifying that design. So whatever we talk about over the phone.
And this will come up, we'll go through this line by line, it'll come up on a lot of items, which are, yeah, we know they're experimental. The question is, if it fails, will we know before it happens? Will somebody get hurt? You know, if it's something, if it was a glass front and you couldn't tell, and the first failure mode is the thing is full of water, that's a lot different than acrylic, which will craze before it fails and will creep before it fails. And it's a lot different than an O-ring that'll leak before it explodes. And so you sort of go down the list, and that's the philosophy we're using on an experimental, first of a kind prototype vessel. But let's go down. Let's just go down the first piece. So the viewport.
Yeah.
So what you're saying is you need we need a pressure test of that viewport and associated documentation from Hydrospace. Have you talked to Will Conan about this?
No, just
Okay.
Tony. I mean,
Okay.
I'm keeping
Right.
everything in house. I'm not.
Right.
I'm not. All that happens is, any time I've worked in a system before, I've worked in 7 different systems
Right.
before I came here. Okay, all over the world. Right. It's an open book policy that you can check before you go for a dive. Put people in there, okay? Because at the end of the day, the pilot is responsible for their lives. That's it. End of story, from the start of the dive until the hatch is open at the end. So, in terms of the viewport, all I was doing was asking for basic information on that viewport. That's it. That's all I'm asking for. That's it.
Okay,
You-
inspection
you-
was performed on the viewport by Scott and I, and it was delivered with cert paperwork.
Okay. So, is the viewport, does it tie in with the PBHO guidelines?
No.
No.
Oh, it doesn't?
It's 8% off of
Well,
the
actually, it
PBHO
does.
line. It depends on how you
Yeah.
want. There are no PBHO.
Right.
Let's just start with the
Yeah.
facts. There are no PBHO guidelines. PBHO admits themselves, I've talked to Will Conan and other members of the PBHO committee, that the acrylic specs for PBHO were developed by Statue, and Statue admitted prior to his death how conservative he was, and everyone knows that they are over-conservative, and everyone I've talked to says an acrylic viewport will craze 1/3 its failure depth.
It meets the
Period.
requirements
And
of
no one,
non-standard
and
geometry.
if you show me someone, so in that discussion with Will Conan,
Yes.
we said this is the shape we want. It's a non-standard shape.
Okay.
Normally it's a hyperhemisphere, and we're doing the flat bottom on the front of it.
Okay.
Well, so that's a non-standard shape.
Yeah.
And I don't think and to find the pressures, you have to extrapolate Statue's curves, which you can tell are wrong because they're straight lines. And nothing in this world is straight line, particularly when exposed to a squared function of pressure. But you have to extend off the chart to get to where we are. Will said if you do that, we're some percentage off, 8% is what they say, when you're looking at a safety factor in excess of 4. So we have determined that in fact this isn't a safety issue, this is a functionality issue. We may go down and make craze. And we have a mitigation plan, which is to put a steel plate in there, and we will then machine a glass compressed fitting from a pressure from the guys at Rayotech who do the glass for the bunch of NASA and the like, and I've met with them, and that will be our mitigation if it crazes over. But it isn't just going to. One of the great things about acrylic, it doesn't just fail.
Okay, acrylic.
And so we have
Experience.
determined this is part of the test program. We're going to test it. I am confident that Will doesn't know what he's talking about. And even Will says the data is wrong, and then he goes back and says, but the data says you can't do this. So it's not certain. It
What
won't
does
be
the
certain.
data, when you say it goes off the chart, what does the data say that
Go
viewport's
to
good for?
PBHO dive. If you go to PBHO,
Yeah.
it's right in there, and you look at the type of they have a chart, and
Okay.
it goes out, and what they come up with is you come up with a critical pressure,
Yep.
which is the failure, and then you multiply by what they call a conversion factor because they didn't want to call it a safety factor because
Right.
they knew every engineer would laugh at them because it's 4 to 10. There's not a safety factor of less than 4 on acrylic.
Okay.
And if you run the chart out, it would say we don't hit by 8%.
It meets the requirements of non-standard geometry.
Okay.
So we've had
And have you got that
lengthy discussions.
documentation from Will?
Oh yeah, no, and he said it's
Yeah,
not
I see it.
certified.
No,
Yeah, we're back to
Well-
yesterday.
no, we're not.
No, so one of the issues is there has to be some confidence in senior management who spent their time doing this and engineering that is doing this. It's not everybody's job. Everybody at Boeing doesn't get to sign off on the aerodynamics. Even the chief pilot doesn't get to sign off to say the wing's designed right. He doesn't even get to sign off to say the control system's right. He gets to find out, how is this done? How do I operate it? What are my limits? And what do you want me to do?
Okay. I disagree with that comment, Stockton, and I disagree, Tony, that you're not going to present that documentation for me to look at.
Okay,
I would like to see it.
okay.
And I requested it in email, you rejected it, and I requested it in person yesterday, you rejected it. You flat out said, no, you're not getting it, you're just the pilot, okay? That's it, you don't need to know.
And
Which
design,
I find
design data.
bizarre.
Oh, it's not bizarre.
Well,
And-
that comment was.
No, it's not bizarre. And the reason why it's not bizarre is what you've done well documenting here.
Yes.
Is you can pick and choose some part of data that you want and
Okay.
extrapolate
Yes.
misinformation, right? And that's what happens.
Okay.
Right. So that's why engineers don't share that. really with the world. You get a report, and some people will know, or certification. You don't see anything behind certification whatsoever. Nobody sees data behind certification, and the reason is for some of the items that you wrote in here, is you would package it differently and represent it in error. And I can go over that.
Can you package it so that the people who aren't as intelligent as engineers can understand it?
Yeah, that's what like a cert paperwork or a report is for. Absolutely.
And do you have that?
No, I don't have time to write that yet.
Yeah.
I mean,
so let's get back to
that's where
the fundamental
we're
question. The fundamental question on the viewport is, and this is where I've been asking for over 8 years, will the viewport fail without warning? That's the one. We're in a testing, and this is what I look at all these things. Will it fail without warning? And to a man, everybody says no. It will craze before it fails.
What? You're gonna have to dumb this down. For me. What's
Optically
that
distort.
word?
So when it starts to stress, it starts to crack over like a bad windshield on a motorcycle.
it'll look like scratches.
Yes.
Okay.
And so that may happen. We are testing a non-standard geometry at pressures way beyond what Clarence Statue did, in sizes way beyond he ever tested for. And he's the only person who ever really did it. And everything in PVHO is based on Statue's work. And they pray to the God of Statue, and they all know, he even said himself, he didn't do all these different geometries. He tested the most of them, and he has great data, and there's lots of supporting stuff. But everybody admits that it was very limited, and that's why PBHO is not a standards committee. It is a volunteer group. It is not like a DOT standards. It is a bunch of volunteers who have their head up their ass in certain ways, and I'm going to go prove that. But that is for me to prove. That's why I'm going to do the dive. And what we may end up with is finding out that, hey, the viewport did craze. It crazed at 3,000 meters. Dive's over. Got to go back. We have a mitigation plan. We're going to put a steel plug in there, and we'll come up with a solution for it. We may find out that it doesn't craze on the first dive. It crazed on the 7th dive. That's why we're going to do more cycles. And same thing. We have a mitigation plan. So we're testing. This is a test project. We're doing stuff. No one's ever done a carbon fiber hull for human pressure like this. I mean, there's a number of things that we're doing that, no one's done a Lars the way we've done it. No one's done, any of these operations. We're doing stuff that's way out there. And the only way I'm going to be comfortable with it is lots of cycles, lots of testing. And, at that point, the proper thing is to say, look, we've done 20 cycles to this depth. Here, you can go look at the viewport. For us to show you and say, hey, Will says it's only good to 3,000 meters, and we're going to 4,000 is not really relevant. What's relevant is this a proven design? And before we put people in there, particularly clients, it's going to be a proven design. And if I have to do 20 dives by myself before I can convince people in the company that it's safe, I'll do 20 dives. I'll do 50 dives. But at some point, you get to that. And this is how it used to be done before we came up with computers and committees and risk assessments. You used to go out and fly planes.
Planes are different. In terms of you going in the submersible, I am so against it. We spoke about it. Everybody else in the company has spoken to you about it. Nobody's said anything against it. I'm against you doing it.
I understand.
We should be putting that sub on a wire with everything that's experimental.
I understand
I
know that's your issue.
So,
and a wire is not without safety issues, for one.
Well,
and secondly, this is how we're doing it. It's just period. Done.
That's it.
I've looked at it. They don't test nuclear subs on a wire. They don't test airplanes on a wire. They could. What you do is you set a testing program where you do it incrementally. It's not going to just go to 3,100 and be perfect, and at 3,200 it all goes away. That ain't going to happen, and I will put my life on the line to say that ain't going to happen.
I wouldn't let him
Okay?
know. And he hasn't heard pushback from me on that whatsoever.
So, that can be your assessment. I've test flown planes I've built myself. I've test flown subs that I've built myself. And as long as I am comfortable with what the safety parameters are, when you first fly a plane, you take off and you land. And the next time you take off and you go to 200 knots and you land. And the next time you go to 210. And then you gradually build the envelope, because they don't just fail. They tend to, you see the stresses are beyond the limits. We have this thing more instrumented than anything. I had this conversation with Will Conan yesterday. I said, every other sub out there is unsafe. They should have strain gauges at every location on a steel sub. How do you know it's still in rounded and get hit by a forklift? Costs almost nothing. No one has a strain gauge doing real-time monitoring. That's what they should be doing. So I take great umbrage at people saying this is unsafe. It's a different approach. And I will do it incrementally, and I will do it safely, and we will analyze the data from every depth. And if no one else is comfortable, that's fine by me as well.
And that's going to happen in the timeline that we've got between doing, eventually when it does get dumped here, to putting you inside it. 8 weeks later, it's on a truck, It takes, what, 2-3 weeks to get there. And within how many dives do you want to be at 4,000 meters?
We'll do 3 to start with. We'll do 1, 2, and 3, and then we'll see what the descent rate is and how long it takes, and we'll do it by 100-meter increments from there on out.
Okay, I disagree with that because the cycles
I mean,
are not
I'm going to
sufficient.
stop in the way, along the way. Well, we have real-time monitoring, so we'll see. The same thing. Every time we go to 1,000 meters, it should be quieter than the last time. If it isn't, then we have serious concerns. We have a lot of mitigation plans in this that are already in place, that have been tested, and that nobody can deny. It's just nobody's done it that way before.
Computers fail. We know this with
I understand.
Cyclops 1.
Right. So you call the dive off.
So to get that data,
Right.
Computers don't fail.
Tony.
Anyway,
Anyway,
we don't have to
okay,
get into that.
moving on.
Yes, but so the answer is yes, a computer fails, so we call the dive off.
And how do you know you're getting accurate data?
Because we have,
The strain gauges.
we test it with the same way Boeing does. Snap a 3mm pencil lead on the outside and see what that waveform looks like. We've had a PhD at the Naval Postgraduate School look at this data. This is one of the concerns I have with a lot of this is the tone here is we don't know what we're talking about. And I've spent 8 years working on this thing.
That is
I know.
not the case, honestly, Stockton. That is not the case. What I'm doing is I'm just trying to get answers and put my recommendations forward with my experience within the submersible industry,
understand.
which outweighs the experience you have in the submersible industry. I know this is your company,
I understand.
but at the end of the day, I've been doing it a very long time. This is Tony's first project. I know you worked on hyperbarics and stuff like that, and you were a diver in the Navy. It's your first submersible project, okay? In terms of getting everything right first time, this is critical, especially with Stockton wanting to be in the submersible. Okay?
I understand.
In terms of your viewport paperwork, let me see it. What is the objection to letting me see it? It's not a bad thing having a second set of eyes who have got experience
Because
in
it
the
doesn't.
industry to actually
We will tell
see
you
that.
it doesn't meet.
Why keep it from
It doesn't.
me?
Well, because it doesn't meet. It doesn't meet the parameters. Period. We will admit to that.
Okay.
Okay. So let's just clear a few things up. One. How many subs have you designed and built yourself?
I am not a designer.
Okay. How many airplanes have you designed and built
None.
yourself? I will tell you that airplanes, cars, and other vehicles these things are a joke. They have some nuances to them, but this is nothing next to an airplane.
The physics doesn't change, neither does the.
So anyway, let's move on. So forward sealing surface. We covered that on the Parker O-ring component. And it doesn't sound like anything. You're going to take your experience and Parker's page from their catalog as trumping whatever Tony has said with Parker or with TIFAB.
On phone.
Right.
He does not have any paperwork to back that up.
I don't get
Correct.
Okay, so the question, so this does get down to a basic question of trust of competence,
Yes.
and that's, we'll get to that later, but let's keep going here. So
Okay.
the sealing face.
Yeah.
So there's a mark. Yeah, we will polish it out.
That's what.
Buff it out.
Closed it.
Okay. This one's interesting. So the segment was glued. Did you ask to inspect the attachment face?
Negative. No.
Okay. If you had inspected the attachment face, do you have certain experience in examining large
Got
carbon
experience
fiber?
of sealing
Large carbon
faces.
fiber.
This is not on the carbon. This is on segment 1.
Okay.
So the metal.
That's
So
the
we
segment, correct.
had no less than 4 engineers there.
Mhm.
It is videotaped.
That's
It's
fine.
on our archive.
Yep.
You can see that.
Yep.
We've glued it on there. So I'm wondering what you believe that you
No,
should have been.
Before I put people in the
Right.
water, it's a verification that Tony
Of what?
saw that actually happening. Okay?
Well, he saw it. I saw it.
He saw it before
Spencer
we
saw
glued
it.
it on. That's it. That's all
I
I'm
saw
asking.
it,
It's
yeah.
not, this is a simple,
But
did you
then-
see it, Tony?
but
yes. You inspected that ceiling face. You
Correct.
inspected that ceiling face.
Right.
That's done. So we can move on from that
So
one.
non-destructive testing we've already addressed.
Have you, this is on the bond line, so are we doing anything on it? I know initially the company, when Tony spoke to everybody initially, we were talking about using a machine to applying the adhesive. It had to be so many thousandths of an inch thick, okay? We all saw it on the video, and there's 4 guys on the top of ladders with spatulas.
Yeah, exactly.
Streaking it on.
Yep.
Okay?
Yep, and we had feeler gauges to make sure we had the gaps on it.
Okay.
And I'll give you an example. The deep sea glider, and I've mentioned this, they have a carbon fiber hull. I talked to Boeing about it. They said it scales up much like ours. They had an aluminum end cap that was supposed to be anodized and was painted. It did 3 dives to 6,000 meters. They brought it back to analyze it, and they found out, oh shit, it was painted, and it literally just came off. The bond line, and what is unusual, is the glue and the nature of the carbon fiber is tolerant of compressive loads, much like cement. Cement can get fractured, and in compression it's fine, in tension it falls apart. Carbon fiber is very much the same.
And is there no concern because we've got 3 dissimilar materials?
Yeah, that's why
together?
they need to be separated.
We have
by
the titanium, we
if
have
we
the
don't, we
adhesive,
can have
we have
right.
the carbon.
Correct.
Everything is
Right,
going to
no,
react differently
right,
at pressure.
exactly. Yeah.
It's engineering.
Yeah, no, it's been
So you
engineered.
have the data on that.
Yeah, we've analyzed the hell out of it so
Yep.
that the modulus are the same, the deflection is the same.
What data would you be talking about? Like what? What's the question?
Well, everybody spoke initially about the carbon. The carbon eventually, there was the potential for it shrinking half an inch. Then there was talk about doing 1/4 of an inch, and then it was back up to an inch.
Okay.
If you got all that sort of data in terms of the hull,
Yeah,
the
they've done all
5-inch
the
thickness,
FEA
you've
analysis.
got that.
Yeah, that's what.
So how much is it going to shrink by? What's the current
In
readings?
order
What have
to
you got for the
deflection at
calculations?
50 inches in the center of the case would be between 0.06 and 0.075
Okay.
inches.
Cool.
Can we go back to the carbon fiber
Yeah.
just because?
A lot of this, let me give it from the layman's perspective. What we're doing with carbon fiber, titanium domes, cyclic fatigue, water penetration, dissimilar metals, the whole number of things that can happen, all of which will manifest themselves in acoustic emission and strain gauge deflection. That's why we have the real-time monitoring. You could never do this. I would never recommend anybody doing this if you couldn't tell the health of the hull from day 1 to day 2. That is the crux of what we're doing. That's why we spent so long doing that. That's why we've had PhDs analyzing the data. And that's why we did the tests at the University of Washington. Because if you don't do that, all of the concerns that David points out are legit. With acoustic monitoring, you get away from that. Now, if it fails, then you have to stop. And this is not something that just happens all of a sudden. It doesn't just implode. It screams like a mother before it implodes.
The FEA's or our analysis, all structural analysis and everything that we did, it's all been validated.
My question, you were talking about that carbon fiber is better
In
under
compression.
pressure as opposed to tension.
Yeah.
And
It's
all
carbon.
I'm hearing is the opposite of that.
Exactly.
So
Exactly.
do you
exactly.
have that document? I mean, I'd like to read
Talk
it.
to
'cause-
Boeing. That's why Boeing is doing it. That's why I've talked to people from not just Boeing, Lockheed Martin. People have realized that this is the case. And it's uniform compression. The challenge
Right.
is when you have non-uniform compression or twisting or torsional loads like you have in a wing. And
Right.
what's being said in the ocean world is exactly what was said in the aviation world. And the FAA took 20 years to approve carbon fiber for primary structures. I've been flying my plane for 10 years before the FAA ever thought you could do that. The entire thing is fiberglass. And the issue is controlling the manufacturing, as having enough overbuild and having higher safety factors with it. And when you look at uniform compression of carbon fiber, it's the perfect material. And when I've been to the Navy conferences, I've talked to guys from Lockheed Martin who are trying to pitch this because years ago they did composite hulls and people said, how do you know it's any good? You could have voids, you could have porosity, you could have cyclic failures, and they took a sub and chopped it into pieces because they thought it would have problems, and it was perfect. And so the Navy has been against it, and the orthodoxy of the submersible world has been against it, and they talk about capricious failure modes, and they talk about porosity, and they talk about all these little things. And the world is coming around to understand that, in fact, carbon fiber is perfect for pressure vessels. It's the only material for pressure vessels.
Can I just
because
ask
it doesn't require extra buoyancy. You can actually get a light structure.
Sure. So here's just me as a diver thinking out loud. If there's a void, say in the middle of the hull,
Right.
and you go down, the pressure is gonna squeeze that
And it's gonna
void.
pop.
Well, and then we're gonna come back up. It isn't.
Exactly.
Isn't that
Yeah, so the
that void
exactly.
gonna get bigger and bigger and bigger? At some
Exactly,
point?
and you'll hear it in the carbon fiber, and you'll also see it in the strain loading.
Well-
Because the thing will get soft. You see this with sailplanes sometimes. They sit in the sun and they start to get soft. That all gets detected. That's why we do real-time monitoring. From the beginning, the time I started this project, the only idea that made sense was that you would have real-time monitoring of the hull. Because you can't do these non-standard things in highly complicated and complex structures unless you're confident you can sense the heartbeat of the patient.
Doesn't that mean
but
though
let
that the hull would get weaker?
Yeah, exactly.
Over-
There is a non-zero probability that we'll find out this hull is only good for 10 cycles to 4,000 meters,
Let me address.
or 50.
Let me address that though. First, So there's an awful lot of rumor in what you're saying.
Mm-hmm.
And to start with, we'll go with whether or not carbon fibers is stronger in tension versus compression. That statement is in fact true. A carbon fiber
Mm-hmm.
is stronger in an engineering lab in tension than it is in compression. What nobody talks about is, in its worst failure mode, compression, is it adequate? That value is orders of magnitude different and better than other materials that
Like
these
titanium.
structures are made out of.
Mhm.
Just the minimum. If we got to go everything in tension, it's why we make like a lot of pressure vessels, lightweight ones out of carbon fiber. If you take that material and you made a block out of it like this, right? And then let's suppose that it's perfect with zero voids in it, right? And you set something on it that's extremely heavy, and maybe even a point load, and you had this same shape out of different materials. It doesn't matter if it's steel, titanium, copper, bronze, and the list goes on. Plastic.
Mm-hmm.
It doesn't matter. That carbon fiber plate will outperform most other materials. Now we can heat treat and do some material science to a lot of these other metals a little bit differently to make them stronger, and it has to do with more complicated grain structures and whatnot. But what you're doing in there is you're changing the shape of it to model more what a carbon fiber structure would do.
And
if you have a void, give me a sec, Stockton. When you have a void inside,
Mm-hmm.
okay, which there's a high probability you get some voids, we'll say, inside the structure itself. Everybody talks about voids inside carbon fiber structures as if it's the death knell, and it can be. That carbon fiber structures are extremely process dependent, right? Which is why I went down to Sacramento to watch this and we video the whole thing, because they are. And what we were concerned about is, you get somebody that does this kind of move. We wanted to capture it on video, but watching it is like watching paint dry, but valuable, right? Watching their process. But let's suppose that void in there crushes, the bubble crushes, right?
Mm-hmm.
And so all your material around it it collapses,
Mm-hmm.
right? And so two surfaces that weren't touching each other are now touching each other, right? And
At pressure.
At pressure, right? Okay, that bubble, or that capability, or that defect, what we call in material science, doesn't move.
So you're saying when you come back...
When you come back up, it goes back to the same place. It does not move. Okay, can it move? That answer is yes. What you need is, in the surrounding material of that defect, you got to have some sort of energy imparted on it in order for it to move within a plane. Now, carbon fiber structures are very planar,
Mm-hmm.
right? So they're like layers and wraps
Right.
and whatnot, right? So in these, not just the fibers next to each other in a plane, because you have the same question in between two this way.
Mhm.
We'll say two layups, doesn't matter what they are, right? You could have a void inside there.
Mhm.
When that collapses, you relieve the stress, it comes back up. The problem comes when it collapses and your loads are vibrating or non-uniform,
Mhm.
which is not the case that we have. And I'll get to why this is so important for us to understand. So if that bubble comes up, we may never hear it. So we can have bubbles in there doing this forever and never cause a problem.
Mhm.
And it doesn't matter really if 50% of that has voids in it. It's like 50% of the volume has voids in it. Now, would we be concerned with those items traveling? Yes. And is 50% the right number? I'm going to say no. I really don't know what acceptable void content is going to be. But what you are concerned with is those structures when they come together in those interstitial planes, right? The glue is what holds it together. What nobody talks about in carbon fiber structures is, sure, the fibers are strong in tension, and they're not as strong in compression, but they are strong. Okay. What really holds these things together is the glue.
Right.
Nobody says, did you put the right glue in there?
I'm asking, did you put the right glue
We
in
put the
there?
right glue in there because it's a misunderstood thing, and these are rumors, and this is the problem. This is the problem with taking misunderstood data and then publishing it, maybe in an incorrect way,
Mhm.
right? It's really the glue. It boils down to the glue in between interstitial places, and this is why. If I took a thin piece of glue here and collapse this on top and wanted to peel it off, I think we'd all say that it's not going to come off, right? But what if I put a nice thick glob of glue on here and put it on there, and then we peeled it off, right? Sometimes those don't hold. And when you do this with super glue, right, you see this a lot. The instructions tell you really, really, really small drop, right? More is never better.
Right.
And the reason why more is never better is it changes your stress strain profile from plain strain to plain stress. And so it matters really how thin that glued interface is, more than anything. So, right? So in the entire structure, give me just a second here. In the entire structure, what's important for the entire design is the entire structure moves at the same way. And we want it to move. Skyscrapers move. They all have to move, right? Now, to move, we had to match a principle called modulus. And not to go into that, our design matches that modulus all the way through, right? And the reason, to take it back to why carbon fiber structures, especially in these solid pieces in uniform compression, are so good is metals have the same issue. They have what are called defects inside, right? And there's different types of defects. We call them dislocations. You have like plain dislocations, screw dislocations. And in these dislocations, what nobody talks about it in a metal is if you go up in an airplane and you see your airplane wings going like this, the reason why metals are flexible and like carbon fiber is really, really stiff is these dislocations, voids, move. And they keep moving in the lattice structure until they reach a free surface. And then it just kind of pops out. When you run out of dislocations, right, it's not flexible anymore, then it becomes brittle.
Right.
And you can see this test in copper pipes. Copper pipes are, if you ever take a piece of copper and you bend it, you can bend it one direction. But you go try to unbend it, it's cold work. You can't unbend them anymore. And the reason is all those dislocations inside our voids went straight to the surface. There isn't anything in there to allow it to move.
So let me bring it back to the submersible world. So if you look at autonomous vehicles, they're all carbon fiber. The deep diving, the deep sea glider, the LDUV, they're using carbon fiber because it's 3 times better on a strength to buoyancy basis than titanium. And so the world is going that way. The manned subworld is dragging its feet, kicking and screaming, but they're making very expensive AUVs and all kinds of expensive equipment that is all carbon fiber. And and as I said, I've been to conferences on this stuff. I've talked to Boeing's top people. We had our contract with Boeing. I've spent countless hours down there talking to all of their composites people, and they had drinks with Mark Nagley 2 weeks ago, and he was all concerned. And he said, "Hey, I'm really concerned about you. You're going to go in the sub." And I said, "Mark, tell me I'm wrong. Will I hear it on my acoustic monitoring system way before it fails?" And he said, "Yes." I said, "Then I'm not concerned. I'm not concerned that I may end up with a sub that doesn't work, or a sub that can only do 50 cycles. And we got to make a whole new. If we could get 50 cycles out of each hull, it would still pay. We just go make up a bunch of hulls. We will know I will know before it fails, well before it fails, and we will also know that it's starting to get weak. That we didn't. One of the concerns, you get porosity. That rhino liner doesn't work, and some water gets in there, and it freezes, and then it starts to create voids. You'll hear that too. We will hear everything. So, and I'm betting my life on it. And I have asked everybody I possibly can, and nobody with any knowledge in the space has told me I'm wrong.
And we validated it.
And Boeing has a reason to tell me I'm wrong.
So why was it the safety factor that Boeing were wanting? They've been willing to make it for 10 or 9 inches rather than the 5. Was it just the safety factor? Is that?
Well, they want it for 6,000 meters and a 2.25 safety factor, and they wouldn't do a 90-10 layup. They only do 40-40-20 because they don't have data. Because in the real world, nothing gets uniform loads. Everything has a torsional component to it, and so they don't have models to do it. Even though they admit all your loads are orthogonal, they wouldn't do it that way. Nagley told me that when he looked at the deep sea glider, which is a 6,000 meter hull, and he scaled it up, and it turns out to be a 5-inch thick hull, and that would be for 6,000 meters. So he's looking at it, and he says, well, maybe we'd be 7, maybe we'd be 5, but it's Boeing, and they're adding on, safety factor over safety factor.
And what is our safety factor?
Well, it's supposed to be 2.25, but I know it isn't, because it was supposed to be 2.25 on the 3rd scale model. There's no way that should have failed at 6,500. So what we told Spencer was we wanted a 2.25 safety factor at 6,000 meters depth. I will guarantee you that it's not there. That's what he designed for, but there are all these anomalies, and he's doing a wet layup. I mean, that's not the same as a Boeing process where they put each fiber down. And Boeing is very concerned to get it exactly right because weight is costly to them. Weight isn't costly to us. Weight's what we want. And so originally the hull was supposed to be 4.5 inches. I said, let's make it 5, just for extra shits and grins to have more. So I think I have very little concern we're going to have a problem with the carbon fiber. The weakest link in the entire sub is the titanium dome.
So what do you think the safety factor is with the size and the way that we laid it up?
With the thing, less than what we asked for.
The case?
Yeah.
Yeah.
The manufacturer's reporting over 2.25 at 6,000.
6,000. So at
But you're
4,000,
saying that's
4,000
you're
is like
saying
3.5.
that's
Yes.
That's what he's
That's
saying.
us.
That's the best data we've got.
That's
And that's
the
the
best.
same thing with anything. You'll get engineered data, and then you go out and test it. So, you know, you can have an engineer who says the landing gear is good for X, and you go out and test it and it breaks. That happens all the time.
So he's saying, sorry, 2.25
At 6,000 meters. 6,000
so
meters.
it should conceivably go to 10,000?
Correct. Yeah, it should not fail. I'm telling you that our experience with Spencer, everything Spencer has told us has been wrong, which is the depressing part. Every part that he's told us is wrong has been in our favor. So on one level, you go, holy shit, he is one of the living experts in carbon fiber. He's got 22 patents. He makes all kinds of stuff for General Dynamics and Fawcett and everybody else, and he's done a bunch of testing.
Mm-hmm.
But he's an old dude. He's weird, and he does it with older software, and he has understood the secret of this whole thing, which is it's highly tolerant of wet layups and manufacturing defects in compression. And so when you're Boeing, you have to be as light as possible, and so they know it down to a rat's ass.
Who makes the vehicles like the deep sea
glide?
glider and
Boeing's
stuff?
been
Like,
doing it.
That's
Yeah,
Boeing makes
yeah,
it?
that's why I went to Boeing, because I saw them making the deep sea glide. I was like, hey, that's our thing.
Mm-hmm.
Something to
But
understand.
ATK does it, General Dynamics does
Yeah.
it. They make housings for intercontinental ballistic missiles out of it. They make all kinds of stuff. You look at what Paul Allen's doing with his giant strato launcher, and the carbon fiber is the way to go.
Boeing does not have internally in the entire company does not have the allowance provision and capability to analyze a structure like ours. They can't do 0-90, so it forces them to a totally different design. You can't compare the two.
Yeah. And that's because under their software doesn't, they have to validate and get allowables for a certain layup, which requires a bunch of work, so that they can have rats on. We know how this is going to respond to different load structures, and unless they have it, they can't put it in the software.
How do you document that?
So anyway, let's move on.
Can I ask one more question about
yes.
the glue? So you said
Yeah.
it's the right glue. What kind of glue is it?
I can't remember. I have it in the report.
It's not Elmer's.
It's in the reverse.
Yeah.
No, it's a. Yeah,
Oh
this-
no, it's Elmer's big brother.
Yeah, no, it's a. Yeah, we've got the.
Is it specifically for like high pressure environments, or is it
Yeah, it's
or is it just a
yeah.
regular?
This is
I mean,
where do
not
we
to
get
say
the stuff? We get
regular.
it from,
yeah.
not from Torrey. I can't remember where he bought
Yeah,
the
so
carbon fiber.
actually the glue has to be so specific because the wet layup, which is circular, when we did on the mandrel, we combined that with what I call pre-preg axials. That has glue already in it. It's a little hard. Okay,
And that
so
was-
that glue has to react with each other. It's,
Right.
it's extremely specific.
Yeah, the chemistry there is non-trivial, and
Yeah, so-
and in
but it's
the
two
one
different
that in
types
our
of
third
glues?
scale where you can look at and see that it basically failed a quarter in, likely that was the pre-preg, which has to get to a certain temperature before the glue will now merge with the wet stuff. So you basically have the fibers go in, they get dipped in the resin, and then they get wound like a baseball, and then a person hand lays up.
Right.
So again, manufacturing defects with a squeegee, you can get bubbles and everything else, and then it has to go in the oven, and if that inner piece doesn't get hot enough, then it's not going to, the glue won't flow, and you'll get what we had, where you could see it at a quarter in, it just totally sheared. So we went down and said, put thermocouples in this thing. Spencer's original estimate of how long it was going to take was something like a couple of days in the oven.
3 days.
3 days, and it took how many?
A week.
A week.
But his total
But
manufacturing.
if you think back, when he did the last one, he probably went with his thumb on the scale. He is a very empirical designer. He has his problems, but he understands this more than anyone else. But he's got his flaws. So we go back and say, this is built way better than the last one. It's larger, which is better because the fibers are smaller in relation to the distance. It's thicker than it should be, and he's taking greater care, and we've watched it closer. That I'm confident that this is closer to a 2.25 safety factor, but we both have serious concerns. We have serious concerns with him. I mean, we've had our vendor issues. It's not like we're just going into this thing blind. I mean, there's a reason why he and I flew down to Benicia so much and flew down to see Spencer, and we're holding his hand and pushing and making sure we had the documentation and did all that stuff.
How's the relationship now?
He's not going to talk to us.
No.
Yeah, because we cut his bill because we had to spend all this money to go to Unico, where he said he could machine it, and he couldn't. His machine couldn't take it by an inch.
So who's going to make Cyclops 3 then?
We'll probably find there are a number of vendors who can do it. So even North Sales, they do. People who do carbon fiber mass One of the reasons I went down this path was talking to Tom Perkins about his ship, and he had a fiber optic sensor inside the masts that were all carbon fiber. So there are a number of players that can do it, and we have the
Carl
magic there.
Spencer doesn't have, or not Carl Spencer, Mr. Spencer
Yeah.
doesn't have the,
Intellectual property on it?
yeah,
No, he gave it to us. We have, what you really need to know is the material and the resin that's used and the process side. And the next time we'll get either BMW, there are a number of better carbon fiber shops than Spencer. Spencer has this niche, and I went to him because he had all the data from testing Steve Fawcett's hull.
Right.
And so that was the primary driver of going with him. He's getting old. We think he may be getting senile. He's got heart trouble. You know, he can't stand up for long. I don't know what was causing him to be a little unusual, to say the least. But there are no shortage of people who can do this now that we have the tool and you have the basics to it.
Was Steve Fawcett's hull pressure tested?
Yeah, they pressure tested scale models of it. They pressure tested. They were pressure testing the main one, and the glass failed on the front. But they had put, like we did, giant aluminum plates, and they had pressure tested stuff. They took it to destruction. They put known voids in it. He spent about $7 million, which is what we got to ride on. And the same thing, you know, Spencer worked with Virgin Galactic, and that didn't end well because they're all odd dudes. Yeah, they're all odd dudes.
They went to full ocean depth
Yeah.
on that carbon fiber hull. Full ocean depth.
How thick was that?
It's
Oh my
7
God.
inches, but
It
it's
was-
small diameter. It's like 28
Yeah, small
out,
diameter.
so it's
It's
a small tube. So let's keep going here. Hatch hinge. We're still working on hatch hinge. I mean, you know, this thing is, you know, that we know that's the number one thing. That dome swings out, it's going to fall, smash somebody's. That's a death trap. And so there's a lot of work going into the hinge and the dolly and the restraining mechanism.
Yep.
You know, I was telling Scott we might even put an airbag on there. You know, get to the surface, blow an airbag up so nobody gets hurt. That is an identified problem. Forward horizontal support. Yeah, I haven't put the nuts in. I don't know. It's not. We weren't ready to. It's not being delivered. We delayed this to next
No,
week.
he didn't come ask me about that, so we have it on a list that's being closed out before we actually go.
Yeah, that's fine.
Carbon fiber hull. We covered that. You know, it's there. It's been covered. Ballast bag. Hey, that's mine. Yeah, maybe it's got some glue. Maybe it's got some leaks. Maybe the activator doesn't work. We're not leaving the harbor, no matter what we do. If I went and paid $10,000 to go get a rotary actuator from somebody, we'd still have to test it. We went and bought the vent valves from Hydrolite, pieces of shit. You know, we had a vent valve wide open. They were, you know, they don't have good drawings. They didn't have, you know, I mean, you can go buy expensive equipment that's proven. We got to prove it on our hull. And that's all about being incremental. We don't leave this harbor here until I got a drop weight, because, I made that in my basement. It could fail. Yeah, it shouldn't. I mean, logically, it's an oil-filled motor that should be able to handle it, but I don't know. So I need multiple backups. Segment 2. These guys looked at it before you put the O-ring in there, right?
That was Scott and I.
Yeah, so there were two eyeballs on it. They torqued it. They put it on. They checked the O-ring.
There was 3 eyeballs on the torque.
Non-distressing. So you got segment 2. Okay, this is different. Glued onto the. Why is that different than the first one?
Segment 1, segment 2.
Segment 2 it's titanium and just an O-ring. So it's not glued to anything. We call the segment 1s are the ones that go
It's
to
glued onto
the.
the carbon. The one that's glued onto the carbon.
So those are called segment 1s. So we have 2
they're
segments.
both called segment 1.
Yeah, as an aft and forward.
Okay.
The ceiling face was the one they both inspected. Same with the aft dome. Aft dome ceiling face, same thing. They inspected it. Exostratus. Okay, so dissimilar metals. Yeah, we're going to put some anodes on it, but the principal metals are the dissimilar metal issue. You got aluminum, steel, and titanium. In that, the valence of aluminum is the one that loses. It is not going to be a safety issue. It may be a durability issue, but we can put magnesium anodes on it. That is the plan. It's not done. It's not going to matter dunking. Here it's not going to matter. There are a lot of boats with aluminum and steel.
But still, that's a design question. Like, the intent is the way that it is. There's no dissimilar metal issue right now. Or is there? Like, what is the issue that you're bringing up? The fact that there isn't any? Or the fact that we
there
don't
isn't
need
any
any?
anodes.
What's that?
The fact there isn't any anodes.
What if we don't need any?
And what if the
things
aluminums are
electrically
anodes?
isolated. But what if we don't? So my question to you is, how do you know that we do?
Experience with subsea vehicles.
Because everything in the water has one.
And
That's a good question.
I mean,
Anodes are so cheap. I mean,
Yeah, we'll
in
throw
the
'em on. I
scheme
mean,
of things, they're so cheap. Why not? I guess.
Yeah, we can throw
Can
them
you?
in.
I mean,
We can throw them on. We can replace them. We have them on the motor thrusters. It's not a huge issue. One of the things that's unique about what we do is, as opposed to having a metal hull where you have a huge problem with ground faults, we're hugely isolated from all that because of the insert and the way everything's data and not current. So it's different than you would see in a metal hull. But yeah, we can throw anodes on it, and magnesium would be better than zinc.
But keep in mind, from a design perspective, right? If we constantly went down the path, say, well, why not? It just doesn't. They're just small and they don't cost a lot. Put it on there. Eventually, you're strapping bubblegum to the side of these things, right? So
I get that.
And,
we address the
and more
technical,
importantly,
right
the
now,
safety
there's
issue.
a-
This is the question of, is it maintainable? If we had a problem, you'll see it. You'll see all kinds of, where these things are joined, it'll corrode and it'll start to go. It's not the kind of thing that happens instantaneously. You end up with a non-maintainable vehicle because bolts start to fail and things start to rust out. That's a maintenance, not a safety issue. But anyway.
But just a question: would having anodes on there potentially prevent that from happening,
Correct.
as opposed to just waiting and seeing if it happens?
Correct. Yeah.
Well,
No,
it depends on
that's
your
what
two
I say.
metals that are put together, because the metals on the electronegativity scale, you can't just pick any anode and stick it on there.
But generally, yeah. I mean, it's not. To me, it's sort of not a major point.
Right. No, I get that it's not
yeah.
a major point. It's just that
It's a-
to me,
yeah.
it's a. I'd rather. I mean, I'd rather go into this with preventative measures as opposed
Correct.
to
Yeah, that's
trying
what
to
I'm saying.
fix it after the fact.
Yeah,
where it's
but-
like, oh shit, I guess we should have put
So
some anodes
take it
on
from
there.
this perspective. If you want to do anodes properly, you need to do a proper analysis of the structure, where to place them,
Right.
how much to place them. We have so many other things on the engineering to-do list that this doesn't percolate to the top.
No, I
And
get
so,
that.
yeah, we can just stick them on and put them all over the place, which is how most people do it. But properly, you should analyze the actual structure and know how big they should be, where they should be. That has to do with, are you going to be in a marina or not? Are we sitting in the water or sitting on the lawn? There are a whole bunch of issues. It didn't hit the top of the engineering, let's go analyze this to hell list.
Yeah, not only that,
Understood.
but there's specialty engineers that focus on this. We were neighbors with one in
Yeah.
Woodinville, and they came down just to check out our subs, and looked at antipodes and gave us some recommendations on, that's why we have magnesium sitting
Yeah.
on the thrusters.
Yeah. Same thing on the electrical pods and anodes.
But to me, like
Yeah.
this issue is we're one of the difficulties and challenges that I think we have at Oceangate is we have basically two different branches of we've got this R&D side and development side, and then we've got the operational side. And some of our challenges on this communication, on this team perspective is like we got the switching hats between those roles, right? We have this where we're in this
Right,
development,
and we're still going,
this
and
R&D.
part of this is trying, normally, engineering makes the vehicle and operations operate. In the past,
Yeah.
operations made and operate, which is how
Yeah,
everybody
and
else
it's
does
just
it.
switching hats and understanding those different variables is not an easy transition
Right.
for people to make.
XNU battery, that's not the final securing mechanism. We may clamp it, we may band clamp it, but we're still waiting for the second battery, which hopefully is here next week. Vertical thrusters, this is just for getting it wet. We're going to have a fairing over them. They'll get tied down. Same with the horizontal thrusters. We're going to put a right angle connector on those eventually so they can come in. We'll be strapping them down. I mean, we know it's a little gangly. But the real question we have to answer is, what's our battery life? What's our maneuverability? Can we turn this thing? Can we, does it function? Does the control system have the robustness that we need? Or is it like the problems we had with Cyclops 1 where the computers are failing every 5 seconds? That's the answer I want to get as soon as
Computers
possible. And having cables dangling around, I could give a shit. I'm not going to be, before we go up against a wreck, yeah, we're going to have those things covered. I'm not an idiot.
Stockton, don't think I was trying to make you look like an idiot. On Friday, we agreed that I was going to do a quality inspection report this week. That's the only
Right,
reason
and we've
this
talked
is
about
here.
when we were going to go through and we were going to show you everything in the sub, and that's been
That was
pushed
the
back.
training side
No,
of
that
things,
was
which
so
made
you
clear
could ask.
last
I said I wanted you to be aware of what was going on in the sub, so you
Okay.
could ask intelligent questions to say, hey, what is the fusing? Where is the fuse? Is
Yep.
this fuse? Why is this wire there?
Part of the training.
And that's been getting pushed off, and the update meetings have been going. So this is that part of the reason this is sort of premature.
This is nothing of the intent.
None of it.
No, of your what we're calling just a quality,
Yes.
whatever. None of this
Okay.
was part of that.
What
Part
was
of-
the
part of the
intent
handoff.
then?
Part of the handoff. To go through and understand, how do you turn it on? Like, this is where the breakers are.
That's
These were
not
the
quality to me. I
Correct.
guess
Last
there
Friday,
must have
last
been-
Friday it was agreed at the
He
meeting
can-
that I
he
was
can
going to
look
do a
at-
quality
he can look at
inspection
a
this
bolt.
week.
He can look at
That
a
was
bolt
it.
and say,
End of story.
Did you chart that?
This
Yeah.
is true.
Yes,
I did say,
I am.
but we said that the purpose of the go-through was before you could do it, the issue was a quality from an operational perspective.
Right.
What you've done is a quality from an engineering perspective. I didn't hire you to be an engineer. I hired you because you understand operations.
Correct.
And so in order to determine the quality from an operational perspective, you need to know where are the 24-volt lines, where are the breakers. Hey, that's not right. That thing needs cover. There are a bunch of things operationally.
Well, that wasn't clear last
Questioning
Friday.
the carbon fiber would have never been in there.
Yeah.
I didn't hire you as a carbon fiber expert.
No, you did not.
So
But shouldn't he as the head pilot and me as a potential pilot be at least allowed to ask questions so that we have that peace
you're
of
welcome
mind?
to ask questions.
Absolutely.
But if you ask a question about an O-ring and we give you our engineering answer to the O-ring and you say I don't believe it, I don't know what else I can do there. So yeah, everybody's welcome to ask all the questions, and they're welcome to see that we've got the acoustic monitoring system, and you can see it, and we've shown it. People sit there and you can scrub it and hit it and see that it works.
We've never
Yeah.
hidden any of it.
Here, I'm coming at this from my accounting background as an
Right.
auditor.
Right.
And I can have a client tell me his books are perfect.
I know.
I don't trust him.
Correct.
I mean, I may trust him as a person.
It's trust but
trust
verify.
verify.
Correct.
And I
But the
feel a little bit like we're getting some pushback on the verification piece. It's a trust me, and that's difficult.
The verification is the testing. So the question is, I'm not asking any of the pilots to make an engineering assessment of the sub. What I'm asking them to do is to make an operational assessment of the sub, which is, how much testing do you really think you need? And David might say, hey, given our problem with the previous thrusters, we don't have 100 hours on the computers, I don't think we're safe. Or there are a number of those things where we come and say, this is the amount of testing and operational experience I believe we need in this situation. On something like a 24-volt charging system, it may be, hey, I don't think we need a lot because I've seen it and it'll work, and maybe we need some other elements for safety. But it's the testing regimen that we're looking for, and that's how we validate it. So you validate it by testing. Having everybody go over the engineering and having everybody look at the certs and the docs and the rest of that is irrelevant. What they should be looking at is, how many cycles are there? What should I look at? Can I tell when this thing has failed? Can I see when there's a component? Can I do a proper pre-dive of this unit? If somebody comes and says, I don't believe this acoustic monitoring, I just don't believe it, I don't like electrons, I don't want to hear it, then they shouldn't dive this. Period. I mean, if you don't have confidence in the acoustic monitoring as a method of detecting failure in carbon fiber, you should go this up.
Ultimately, your life is always in the hands and trusting an engineer. You do that in your car.
Which I
You don't
get,
verify any of that.
but they provide me with the manual so I can read it and
but the
understand
manual-
it.
The manual doesn't tell you anything.
But
It
that
doesn't tell
goes-
you anything.
No, but this
Tells you where the
all goes
switches
back
are.
to what I was saying earlier. It's like, we are on Cyclops 2, Titan, we're in this research and development phase. We need to, as a team, realize that we are in this development phase, and we're not going to get performance reports from engineering during the development of a vehicle. It's just, I get what Tony's saying. We're collecting data. We're going to get real-time data back from these testing, and then come up with a summary, and then determine based upon that testing what our limitations are for our operations. We're going to have, and we'll have that feedback, and then we can make the determination. Great. What are our operational procedures based upon that testing? And
One of the things
what are our boundaries? Can we operate, and this will be for the large platform as well. What sea state boundaries are we going to? We have to develop that as a collective team, and based upon the existence of the vehicles.
They're in the past, before we had computers able to analyze everything down to a rat's ass. People would build tests, and that's how you innovate. When you get computers to be able to do everything, now it's design, and they keep going. And what the ocean environment allows us, it is mighty unfriendly on the surface, but once you go underwater, your loads are all known, they're repeatable, and they're linear in their onset, which allows you to do things in the old world method, which is the efficient way to do it. We could spend forever analyzing what's our descent rate, and we could do a hydrodynamic study, and we could do all this stuff, or we can go out and test it and tell us what it actually is. And so we're taking, it completely falls in the face of an Alvin design or anything else. And the reason Alvin cost so much is because they spent way too long on stuff that was more about meetings and making sure they had massive consensus, as opposed to somebody standing up and saying, this is the way it's going to be. All the big developments, whether it was the Saturn V program with Werner von Braun, or whether it was the early nuclear stuff, it's always one person who sticks their foot down. Otherwise, you got a committee, and it takes forever and costs a lot. So, understanding how, I think from a pilot's perspective, number one thing, you need to get some confidence about acoustic monitoring. And if you can't get there, and some people can't, some people say, look, I'm not going to trust my life to a computer telling me that the patient's heart isn't working. Then this isn't the right place to be.
Yeah, I have no experience with acoustic monitoring, so I mean,
Once you see them, you'll see this thing. It's amazing.
Yeah.
You'll sit there and go, wow, I can hear crackling of shrimp. I can hear all this stuff. You'll know this thing's running.
Everyone's going to have to go through this process of this transition from R&D to operations and be comfortable with it.
Right.
Every single individual is going to have to
up.
go through that process.
Hey, Bonnie.
And
Go ahead. Sorry.
yeah, it's just, we're all going to have to go through that process because we're doing new stuff. It's just part of that path.
Check this out. If I take this lead right here, 0.5 millimeter lead, and I will show you, I have 9 times the instruments installed in that sub right now than Stockton asked me to put in. And if I take this lead and I break it on the outside surface of segment 1, we will see the braking impulse on the forward instruments. And I will see also a time delay from the instruments from the first ones to the last ones.
So how do you know the difference between pencil lead braking and something popping inside this?
That's a good question.
And that's why we hired a PhD in
That's a very good question.
statistics.
Or
from
biological
the
science, right?
Yeah.
Or biological.
Yeah, no, that's
squid
what
hitting the side.
yeah, so we're gonna probably have an external transducer so we can look things like shrimp crackling and harbor porpoise. We may have a lot of false positives.
Right.
It
And
turns
that's the
out,
question.
I can answer that. No,
Really?
let's not do it now, but I'd be happy to answer that if you're really interested in.
Yeah, well, I mean, it is my life on the line in this thing, so yeah, I feel.
I'll explain it.
Okay.
I will ask
So anyway,
I'll explain it.
so
Steve.
let's keep going on this thing.
So I think what would be beneficial, outside this meeting is, this is, like I said, this is a journey for everyone at Oceangate, and everyone that's going to be involved in our operations in, having, and we have this moving thing that's going to be developing. We're going to be, the performance reports based upon testing, we're all running fast and circling around and making sure that we have this really effective communication. It's going to be very challenging given our timeline, and allowing each person to do that process and get an understanding of complex things that they're not an expert in. It's going to take great effort by this team to communicate. And I just want to. We need to think about that holistically at Oceangate, how to manage that.
Agree.
Okay, so let's finish this off. The last 2 items have to do with the flooring and the vinyl. One of the questions is, what is the appropriate flame test? So there's a flame test for fireproof stuff for your house, because you have an open flame. And there's a rational flame test for a submarine, which you don't have an open flame, you do have wires that short. And the real
And
test...
oxygen, right? I mean,
Yeah, well, you got, it shouldn't be a high oxygen. It's not a high oxygen environment unless somebody decided to crank it up. So the question is, can you take a 24-volt battery and a wire and cause this thing to flame up?
Which flame standard did you use? No, you wrote it on here as like some sort of hit list. You asked me about PBHO. What flame standard did you use?
The flame standard, we took it outside and set it alight for 3 seconds. All I did was, it was a test that our CEO asked me to do, which I did.
On the acrylic.
The tape.
You did it on the flooring.
Not on the acrylic, that was on the flooring. I did the tape, I let you know on the
Okay.
tape.
Mhm.
You turned around on the Friday o'clock meeting and you said to me, take a sample of that HDPE, take it outside
Okay.
and set it alight. I
Right.
did it under instruction from
Okay.
you.
Okay.
That was where it came from.
Sounds good.
Okay,
Okay.
so
I
we need
just
to
asked
look
you
at
about the
it.
standard. I've already done the test. Did the test long before.
Okay.
And I'll let you know that. I also let you know when I saw your little flame test that it was fine. But you still wrote it. Why? The engineer already told you it's fine. And I already told you about my previous tests.
What test did you do?
Why
I
are we
mean,
retesting it if we already tested it?
Exactly.
He did ask me, so that's a fair
Correct.
enough reason for it.
Okay. But even if you test it again, we've already had this conversation.
So, one of obviously a concern here is, to me, it's clear that there is not a lot of confidence on your part in the engineering that went into this vessel, and that your experience in other vessels gives you serious concerns about the safety of Cyclops 2 from a very fundamental level, from the carbon fiber, and then you have serious concerns with the safety of the test procedure and me going in it and not being dropped on a road.
Correct.
And you have some very serious concerns.
Correct.
And I don't believe we have alleviated those concerns in this meeting at this point.
Correct.
And I don't believe we're going to alleviate your concerns.
Correct.
That's a problem. You're a great pilot. There's no question about that.
Sure.
And you've done a great job on Cyclops 1 and Antipodes. Clearly, Cyclops 2 is not something you are eager to jump into, because it is, from what you're saying, you have these serious safety concerns that you're not going to get a comfort level with.
I do, and this is the first day we've ever had proper sit down, all of us, to discuss all this. Okay? I now know where we're at in terms of PVHO guidelines. The viewport, we know the viewport may not make it. Okay? We know about the carbon fiber. Okay? We've all seen the samples. The samples, they're a mess.
They're not samples.
They're not
They're
samples.
they're
They're
scrap.
part of our winding. They're scrap off the
They're
ends.
scrap.
But my thing is there a genuine question? Is there anywhere out there that can do non-destructive testing of that hull to verify the integrity? And I know in a lot of products out there that have got carbon fibre, they do have voids, which is acceptable. In your aerospace industry and stuff like that, in the boating industry, it's acceptable. What are we setting the baseline against right now to warrant putting you in the water, under power, dropping yourself down to 4,000 metres? What is the justification there in doing that without having any proper baseline data?
Right. And
from
I talked
engineering?
to Boeing about the
Proper-
same issue and said, how do we inspect it? So we have a 5-foot diameter CAT scan, but it will not detect micro voids. It'll only detect gross delaminations.
So why don't we do it?
And what's
Because it's got steel on it now. It
What's
can't be
the
done
problem?
now. And my question is, the actual test, we get a perfect test environment on every goddamn dive. Something you can't get in flight. Every dive, we go through 10 feet, 20 feet, all the way down. We get the exact same pressure, and once we get down a couple thousand meters, the exact same temperature. Every dive. And that gives you the ability to test. Every dive, it's collecting data, and we're going to get heuristic data that'll say, shit, I'm at 2,000 meters and it's noisier than it was yesterday. You better call it off. That's what we've been focusing on. That is the value. That allows us to do this. And so going and getting something that comes up and says there are voids or there are not voids, I don't even care if they tell me there are 1,000 voids. I'd still go do it because I want to see the data as it goes down. I am confident that even if there was massive voids, it's still a useful hull. It might only be good to 2,000 meters.
It might only be good for 20 metres.
No,
You don't know.
I don't know, but I mean,
We
that's
can't-
not rational.
Nobody
you can
here
make
can
that.
turn around and say they
Exactly.
know what that hull is good for.
Right, exactly.
Get a
So I can
baseline.
tell you this.
You can bring your results
Okay.
back from the dives.
Right.
You get your popping, your crackling.
That's right.
Okay. What's to guarantee that those voids were there before he even did the first dive in the marina,
Correct.
or
Yeah,
after
right.
that last
I'll
dive
tell you
where
this much.
Stockton decided
So-
we're scrapping the hull?
I'll ask you this question.
What?
Do you think that hull can do 20 feet in the marina?
Stockton, I don't know.
Okay.
That's my answer. I am no carbon fibre expert.
Okay.
All I'm asking for is information here.
Okay, and I'm telling
Viewport.
you. Right.
Information. I've got it now. We don't have information.
No, we do.
Oh, no. Hold on.
But-
No, we have all the information we need.
Right, okay.
No. You can't dismiss that.
I have
That
to
is-
dismiss
that
it
is
because
not okay.
I've asked to see it.
You don't have to see it.
Tony?
Okay, let's back off on this. Let's get to the what I was getting to at the
Yeah.
outset, which is you're not comfortable with this hull, nor are you comfortable with our test plan.
Listen,
Is
the
that correct?
main thing here is I am highlighting issues that you have seen on the shop floor. Even your wife pointed out that O-ring, you know, the hole. She's
Correct.
like, oh my God,
Well,
that
she's-
shouldn't be
she's
there,
an
should
element
it?
engineer.
I know, but
She also
that's
pointed
what
out
I'm
you didn't
saying.
have a hat on, too.
What's that?
You didn't have a helmet.
Oh yeah, well,
She's constantly pointing
yeah,
that
I
out.
know that. But
Okay.
honestly, we don't know what's going to happen to that carbon. Okay? Any sort of testing we do, we should be doing unmanned to start.
That's your opinion?
Absolutely, and we're all entitled to it.
I understand.
We're all entitled to it.
And where I'm getting to this thing is, this is the future of the company. This is the path I've determined to take. This is the test program I've determined to take. And I've been working on the engineering and I'm comfortable with it. And that's why I'm the only SOB who's going in this thing. And I'm not going to force anybody to go into it,
Yep.
and they can all look at it later. You're not comfortable with that.
So why the change of mind for getting it scanned when it was
Right.
all agreed it was going to get scanned?
Because I
It was
asked
even
whether-
in all the documentation,
I asked
everything was out there.
because I talked to Boeing and they said basically you're not going to get anything useful data out of it.
Because the loss with the
It will
thickness.
show
because it's so
big
thick.
voids, but it won't show little voids.
It
It will
may
give
show
you
big-
No,
may
data.
show big voids.
That's what Stockton
right.
said. It won't
may
show
show
you.
big voids.
No, it may show
So
big
why
voids.
not do it?
It's-
We did. So what? Because we chose not to. Because one, we couldn't find a machine that would do it. You know, maybe if we'd looked in the lumber industry, we weren't doing it with Boeing. So
Yeah.
then the question, could we get to Boeing? I chose a lot of things not to do. Yeah, I could go down an Alvin path. Give me $42 million, I'll go down an Alvin path. I'm willing to not go down Alvin. We're doing things differently. And that's the problem. We're doing things significantly differently than any program you've ever been on.
Correct.
And that is making you very nervous.
These issues
And I'm not going to get over that. And that's my
no,
point.
these issues are making me nervous.
I understand.
For putting people in the
I
water.
understand.
This is
I
visible.
understand. I
That
understand.
it's visible.
I understand.
Okay. Now the viewport, it's visible.
Right. Okay. So
the
my point
deviation is from the original plan.
I understand.
The original plan
I-
last June or July, that vehicle was going unmanned
Correct.
to Penn State.
Yeah, it was.
Yeah.
And we
It
chose
was
not
delayed.
to. Yep. Why?
Do you know why?
Because it was delayed.
No, because
That's
we
what
ran.
everybody
No,
was
not
told.
at all.
Well, we were there were multiple reasons. You know,
Not at all.
one was they wouldn't let us put it in there.
It was
Okay.
it was the displaced volume. They wanted us to fill the inside no less than 94% of its floatable volume inside.
Well, this is news.
Okay.
Okay.
It's for time purpose.
Yes, but anyway, so we made the determination no, and we'll do it this way.
Okay.
And that will happen. And that's the reason we're able to get farther than anybody else. We're being more nimble and we're doing things that are non-standard. And that is
Totally. And I get
that is
that.
not something that you are going to get comfortable with.
It's not a case of get comfortable with. Stockton, I came on board this project.
Understand.
I moved my family from the UK.
Understand.
This project, okay, had a plan.
Mm-hmm.
We've deviated from that plan so much over the last 2 years, even before Tony started.
Mm-hmm.
Okay, it just went a different angle completely.
Mm-hmm.
You've got to agree with me.
I don't know if I'd say different. It has changed, and it will
It's
change a lot.
very much
The
changed.
business has changed. You
Yeah.
see nothing. You want to talk to my original investors about what we were going to do here?
Yeah.
That's a small, nimble
All
business.
that. So for you to turn around and say I am wary of this, yes I am, because there are areas in here
I understand.
that with my experience I can see there being issues, and I'm allowed that opinion.
You are.
I am allowed that opinion.
But
Right.
that doesn't go
So-
in an inspection report. That's an
How did Tony? I'll do what I want in terms of the inspection report. This was an inspection report we spoke about last Friday that Stockton turned around and said,
I didn't
you
say
do
do a
it.
report. I said we were going to go through the
Well,
sub. I did not say we were going to
It
do a report.
wasn't made clear. I said to you upstairs in the afternoon, on the Friday afternoon, we were talking about the whole life support thing, okay? I said, I'm going to go through this with a fine-tooth comb. You never questioned me.
Right. I didn't say write a report on it.
Well, what's the objection with writing a report?
You first figure
It's-
out what's going on and ask the questions and get an answer to the
I
questions so you
have-
can have an intelligent answer to
That's a misstatement, because I have asked him, I have asked you,
Yeah,
and I have
told
asked
you. And you don't believe the Parker O-ring point. Even today you don't.
What's
So,
the ceiling surface?
Tony,
No,
this-
we
no,
do.
Tony,
It doesn't
Tony.
matter. Let's keep emotion out.
Just
All I'm
go.
saying is, we've reached an impasse, okay?
Yeah.
I think that proper resolution here, if you're up for being a contract pilot, is for you to be a contract pilot and to not be in this
Is this a
process.
conversation we have with Tony
What?
sitting in here? You want
can
me
have
to
it.
be a contract pilot?
What?
Is this not a conversation we should be having on our own, not the engineering director sitting beside us?
It doesn't mean he'd like to leave.
I think this is going a different tangent here, so I think the
Okay.
three of us should sit down
Sure.
and discuss this.
You guys want to go,
solely.
man? Well, he's your direct superior, so he will say.
Yeah, okay.
Yeah.
Am I
Yep.
good? Move on? I've never turned away teaching somebody anything. Ever.
So my point is, given that you've stated you're not going to get comfortable with, certainly the test project, with me being in the sub. That's not something you will ever get comfortable with.
These issues need to be closed
understand.
out. These are serious issues,
I understand, and I believe
You
I've closed them out.
understand
I
the
understand.
risk is high here.
I understand.
Especially with this viewport now.
I understand.
It's now been made clear
I
why
understand.
I'm not being given the information
Correct.
by Tony.
Yeah. I've seen the information. I know
Because
what
it
it is.
ain't good.
Yeah. It's good because Will Conan doesn't know what the facts are. Period. And it's fine. You can. It's fine to poke holes and ask questions. The challenge is that I can give you the answer, and you disagree, and you stick with your approach, and you have an opinion, and you will not. I'm not going to get you off if it's not PBHO certified, even though PBHO certification means absolutely nothing. You're not going to be comfortable with it. You're not going to be comfortable, you've said, with a carbon fiber hull and a human being going in on the first dive.
The main thing I'm concerned about, Stockton, is you throwing yourself down to 4,000 metres.
And I'm not throwing myself to 4,000
Stockton,
meters.
the
I'm
timeline-
incrementally testing until I get
This
down
is
there.
the thing. Scott and I have discussed this. I've sent Scott a proper test procedure that should be done properly, okay? In terms of that system going down on a wire. You
understand.
judge it using your strain gauges, your test gauges.
Right.
You get the data,
understand.
analyse it. It's staircasing.
I understand.
Yes, it's the industry. I've been in it long enough
I
to
understand.
know the industry works. Nobody has had an accident for such a long
I
time
understand.
for that reason.
I understand.
Stringent testing.
I understand.
Okay?
Okay.
I get Cyclops, it's not classed. The hull may be classed, okay? Fair enough. But in terms of this system, it's
Right.
all new to everybody.
I
So
understand.
why are we not even trying to follow the guidelines from the industry in terms of doing the pressure testing?
There's an industry hanging on a rope guideline. First of all, hanging it on a rope is not a zero probability solution. It is not without risk. It is not without difficulty. And I am confident that with an incremental stair-step approach down, having a person is just as safe as having them on the surface. You take a 10,000 pound load off the back of a ship on a 3-mile cable. That is not a small endeavor. This is not like taking suds out and dropping it down 400 feet. That has its own engineering challenges. I've decided this is how I am going to do it. You are not going to ever be comfortable with that.
My main concern here, Stockton, I get the gung-ho thing, want to go and do it. I get it. Okay.
It's not a gung-ho thing.
Stockton, I think you have to listen to me here. The main thing which you are sweeping under the carpet here is if something goes wrong with you being in that submersible, okay, your topside support. Those are the ones that are left with the aftermath. Those are the ones that are left to answer to the accident investigation team. Oceangate is done.
I understand.
Everybody says, oh, it'll just be Stockton's wife. That's the only person you could be liable for. Nonsense. The accident investigation team will come down.
I understand.
It would shut the industry down.
I understand, and that's bullshit, but that's fine.
Okay.
The industry likes to say that all the time. What does Carl Stanley do?
That man is different. That man doesn't have it. Yeah, he is different.
If
Very
Carl,
different.
if Carl Stanley has an accident, will it shut the industry down?
I'll agree with him on, I'm uncomfortable with you doing the man test as well, and I've told this to Neil, that the thought of going down to the Bahamas and bringing back a dead body would
Well, you won't.
mentally fuck everyone who is down there, and that scares the shit out of me.
Okay, and if you worked for Virgin Galactic, you got 3 dead bodies. I mean, that's the nature of testing things in the extremes.
Understood. I'm just saying,
And,
it's
and
not just you.
by the way, you won't be bringing my body back. So
Well,
it's okay.
yeah, I know.
Yeah, I understand. I understand the
Back
concept.
in a Ziploc.
Yeah, and so this isn't for everyone, and that's where I'm getting to, which is this project is not for everyone. Okay. And the question is, what I'm getting down to, it's clearly not an approach that you're comfortable with. You don't want to be associated with it. You don't want me to die
Never
and have your
once
name.
said I don't want to be associated with it. I am highlighting my safety concerns, which as an employee of the company,
I understand.
I've been
And I
here
have-
for nearly 3 years now, Stockton.
I
I've
have
seen
heard-
the way it works. I am addressing what I view as safety concerns,
And-
concerns that I have mentioned verbally,
Correct. And
which
I-
have been dismissed by everybody.
I've listened to them, and I have given you my response to them, and
Yes.
you think my response is inadequate.
Correct.
Okay, so that's the impasse we're in.
Well, no, I'm going to keep on coming back to this because where we're at right now is we are at the infancy of this, of
Project.
operating this sub, and we are jumping ahead and jumping to conclusions based upon little operational facts and we're just making a lot of assumptions, and that's why it's so critical through this development process that we collect accurate data. We have performance reports from engineering. And we can take that quantitative data and move forward. And we've done that with the development of the LARS program. And transferring that over, we've developed a new vehicle based upon our performance of that. And carrying that over into the Cyclops program, and that's.
Yeah, and everybody said that wouldn't work. Even Tim said it wouldn't work. Everything I've
but
done
the fact of the
since I started
matter
this
is that
project is people telling me it won't work. You can't do that. It will not happen. You can't. Starting with, you can't dive here in zero visibility with an inexperienced cruise on wrecks. People didn't understand what sonar could do for you. I've been fighting this thing since I started this business, and I don't want to fight it with you. And I don't want to put you in a position that you are feeling like you've been badgered into signing off of me going and killing myself. I have no desire to die. I got a nice granddaughter. I am going to be around. I understand this kind of risk, and I'm going into it with eyes open, and I think this is one of the safest things I will ever do. It's going to be a lot safer than flying a plane, the first plane I ever built made of carbon fiber with a 300 horsepower engine on it. So I have no desire to die, and I'm not going to die. What may easily happen is we will fail. We will get down there and we will find out the acoustic monitoring has fails after 10 hours, or gives too many false positives, or the thing is noisy, or the dome is creeping, because we're going to be measuring that, or it starts to craze. I can come up with 50 reasons why we have to call it off and we fail as a company. I am not dying. No one's dying under my watch. Period. You don't agree with that, and I don't want to put you in that position. And that's why I'm saying contract pilot may make the most sense, because I know you're comfortable with Antipodes, and I know you're comfortable with Cyclops 1, but I can't have you here. I can't force you to work on a project that you think has the potential to kill me and destroy an industry and participate in that activity. And I'm not going to do what you want. Well, that's the impasse.
I don't want to speak for David here, but for myself, and my frustration partially comes from, obviously my background is accounting, so this is all brand new to me. And what I know from diving and pressures and that sort of stuff. The frustration is trying to get additional knowledge from Tony. He's not here to defend himself. He puts up walls, he stops you at, I want to know this stuff, and granted he's willing to teach me about strain gauges, and that's great, but I feel like everything else, it's trust me, I'm an engineer, and you don't need to see that.
So do I.
And that's frustrating. This group should be the most open group. We should be talking with each other constantly. Pilots, engineers, operations, we should all be on the same page, and it's an us against them, and
that's very
that's going to
unfortunate.
kill this company.
And it's been there for a number of years, and it's what I brought up months ago. That is what will kill the project.
And I mean, I hate to throw Tony under the bus, but he
will talk your ear off if you want, but he won't talk your ear off if he thinks you're going to criticize him or he needs to get something done and he just comes to your table. But he
but
loves
sometimes
to be.
if you just ask a question, it's like, hey, can I see that? I mean, I don't fully understand why he's so unwilling to let us
Because
see
they don't
the.
like each other. I mean, that's
I
pretty
get
clear.
that, but I mean,
No, but I can work
for
with
him
the
to
guy.
just say no, you can't see it.
Yeah.
Because, and I mean, he's not saying it in so many words, but he's saying you're too dumb to read this stuff.
Right. No, what you'll see, what his report said, what Will has said, if the shape was like this, it would be good to 3,000 meters. Because we have material here, he says he's only certifying it to like 1,000 meters. It's like, really? That's interesting. And I've talked to him at length about that. He doesn't have any real data for this. He says, well, it's like a cathedral. Well, a cathedral's having gravity. And I keep coming back to Will, because we've been long, you can't have a short conversation with Will. I said, tell me this, will it craze? Will it creep? Will I have warning that it's going to fail? And he said, yes. And then he said, so what's your backup plan? If you're in the Bahamas and it gets to 2,000 meters and this thing's creeping and crazing, you're screwed. I said, we have a backup plan. He wants to know, what is it? I'm not going to tell you because you're a pain in the ass. You've lied to us about thrusters. I didn't say that. But we'll have a steel plate that we can put in there and finish our testing. It's going to be a bit of a problem because we're not going to have a viewport until we machine one in. I mean, we do have a backup plan.
So is it basically like a steel O-ring that you're
No,
going to
it's
put?
literally a steel plate. You take
like
that thing,
you're gonna
steel
just
plate, and
cover
we'll
it.
we'll cut out the inside, and Rayotech can do a insert glass fitting for pressure housing.
And
that's
steel
good
and
for 20,000 pieces.
titanium. I don't.
Yeah. So that's what Hosden's working on. Is okay. What's the shape? Should it be steel? Should it be aluminum? How much is the plug and all that? So that where does it sit so it transfers the load properly? But those are things you don't have confidence in.
Well, we don't have
Those
confidence in
things-
him because
Bonnie
we're not
said-
being told
Yeah,
them.
we're not being
Yeah,
told
well,
anything,
that's-
Stockton. We're not getting answers. We're not getting correct answers. It's been a problem, and it has been a problem since day one. And we have been trying to make it work. This relationship thing. And
They
I
say
know-
it goes both ways. He says he's been trying. I get he said, she said from all of this. So, and the fact is, I know. I'm getting all the answers, and I'm the guy who's listening to everything that Tony's saying, everything that Will Conan's saying, everything that Boeing's saying, everything that Brian Spencer's saying, ATK, GD. I'm the guy who's collecting all that data. Okay? It sits here. And if you don't have confidence in the CEO, then that's the wrong place to be. And that's what it comes down to. I'm not, and anybody can come ask me, have I ever, told you, if you come to ask me, what's this acoustic monitoring system? I know all this stuff. I talk to him all the time. And I haven't rejected somebody saying, I'm not going to tell you. I'll tell you. I just told you what the acrylic is. According to Will, he's like, it won't work at all. And why did he say that? Because he wants to sell us another one. He had more acrylic, and he said, why don't you buy one like this? Because that will make it to 4,000 meters. And I said, really? But it's going to distort, just like the Antipodes hull. I want the one that's flat. If it doesn't work, I could go to that, or I'm actually going to go to the plate. And so, I have all that data, and I'm happy to share it. I don't give what he says, but I'm the guy who's been talking to him. And that's what, offends me is, I've been in this thing. I've been getting this data. I have been collating from experts all over the planet, and I'm still never going to be able to convince you. You've got a history. I know. You've got a history of testing stuff underwater and seeing things. I understand. And I'm never going to convince you. And that's the problem.
To me, these
I know.
These are serious
I understand.
issues.
You said that. I understand that.
I mean, it's health and safety. I'm
I
not
understand.
talking about something that's,
I
you're in a
understand.
car and you know that it's going to fall apart at 30 mile an hour.
I understand.
This is pressure boundary. This is intense pressure you're going to be down at.
I understand.
I want this project to work. I came over here for this
I
project,
understand you
Stockton.
do. I understand you want this project to work, but
Yeah.
I am telling you, I understand that.
Well,
And you just told me, what's the failure
disagree
mode?
with you.
What's the failure mode?
Stockton, it's going to leak.
Okay. Am I going to die because it leaks?
It's going to leak.
Am I going to die?
That.
Am I going to die?
I mean, honestly, they've not obviously exhausted the amount of companies that could be doing scanning of the hull to show what it's like. That was 2 samples sitting out on the shop floor up at Orbit.
Those are not samples.
They
Those
are the
scrap
end
material.
segments from our
Doesn't-
carbon
they are
hull.
scrap. That's called scrap.
Okay.
A sample is something that is representative of the primary. If you look at those pieces of scrap, they're shit, not so shitty, sort of shitty, looking better. The only part that matters is the part that's cut off. When you look at that surface, you start looking at the rest of it. Yeah, it was all back and forth. That was always supposed to be a cutoff. It is scrap. So you can draw the picture. Let's get back to the fact. The fact is, we're not going to get there. You're not going to get comfortable with my approach.
I disagree with your decisions.
I understand. Yeah.
Which,
I mean, that's insurmountable.
That's that's my question. We have this test plan here, or some test profile, right? We have 40 close to 40 days of testing here in Everett before we go to the Bahamas. Is that, we talked about maybe delaying the Bahamas if we don't fit those profiles, or we run into test points within this development,
Right. Show that we're way off. It starts to leak at 50 meters.
Yeah, whatever.
We
have these anomalies,
and how and Tony's even talking about it.
And that's part of this development of this program is we have to collect these data points, and there's real world testing to take place, and we all have to do this journey and be comfortable with that. And
I don't want to force anybody down the journey.
Yeah, but with that said, we're going to have, I've talked to David about, the request for information, the disclosure of things. We're going to have all sorts of questions, from different departments on how to behave and how to maintain. And, some of this upcoming meeting that's for now Monday is going to answer some of those. But we're still in this transitional period, and we're going to ride this transitional period all the way through the Bahamas, and then come up with operational procedures based upon that success or those anomalies that we run into.
What's this meeting on Monday?
Just go to the systems.
It's just a systems review, and that's what Tony was talking about. Okay, well, this breaker does this. This is how you turn on Cyclops 2. This is how you fire up the computers. This is the basic. Going through the systems that engineering has been working on and developing, and starting that transition to operations. But at the same time, we are still in development mode, and things are going to be changing, right? We know that some things have been slapped together. Like for example, the thruster. It's got all sorts of different types of hardware on there. That's not going to the Bahamas, and certainly not going out to Titanic with three different types of fasteners on a thruster mount.
Thing like that.
But that was available, what was in the shop, but to me, I'm not going to sign off from operations for that to go out in a case like that. Is that fine for testing in the marina if we have a rusty fastener is at the end of the world, or if we have a missing anode? I don't think it's ideal, but I'm not going to say, no, we can't go do a dunk here, and just because we are going to have a little bit of rust, and but there's certain things that we are going to make the determination, like if we don't have the right information in from this upcoming brief, we're going to say we're not going to put a person in it till this.
The brief is not a release to put a person in it yet.
Correct.
It's
Yeah.
But
I'm saying it starts that dialogue. It's that dialogue, to me, has not been well established, and it has not been as good as we would all like. But to me, that's just an open book that we're all going to write together and get down this path, so we have an operational sub and we have a successful program. That's the key to me. That's how do we all at Oceangate make this a successful program, because this is our goal. We got a very tight timeline to do it.
So we're still back to square one.
Well, I'm putting my
talking
HR
about it.
hat on here.
Yeah.
What do you need? I mean, what would make you comfortable with continuing to be the director of marine operations here? Are you in an all or nothing, like all of this needs to be, I have to have the whole scanned.
I would like the hull scanned, yes, absolutely.
Is that, I guess the question is that the whole has to be scanned, or I
Cannot sign off on it?
Yeah, I mean, are you there
But
or?
you don't care, you've said.
That's
It doesn't
my-
matter what I say.
That's my point.
Right?
Yeah. That's why I think we're at an impasse, because you have made it clear, these things have to be addressed to your
should
satisfaction,
be.
not to my satisfaction, to
It
your
should
satisfaction.
be.
And on top of that, there's no way you're gonna be comfortable with me going in the sub.
Is there
on
an
first dump.
alternative to
Those are the
scanning?
points that are pretty clear. You stated
I
that
don't
pretty
know.
clearly.
I don't
Has
know.
any option been out there? I don't know. I mean, there's ultrasonics, there's X-ray, there's.
I've
you
talked
know.
to a bunch of folks, yeah, no, good luck. I mean, really, because we had the same thing with the, we had talked to Spencer about doing this so we could qualify it in case we had a problem in the future, and, you know, he's looked at a bunch of stuff, but again, I've given you my opinion of Spencer. I've talked to the Boeing guys. It's not easy. Nobody's made a hull like this. 5 inches thick of carbon fiber, and particularly now that it's got 2 titanium ends, you just took a whole bunch of things. The area that you're most concerned about is the very first part, because the concern that Boeing has is going to broom out, that's where you're going to end up having the biggest problems. Guess what? That's now encapsulated titanium. You ain't going to be able to handle that.
How much is the lip on the edge? I mean, so, I mean,
It's not
you've got,
much.
if this is the carbon fiber, how much
Yeah,
is it?
yeah, much.
And probably like your finger size.
Yeah.
Oh, okay.
Okay. You've answered my questions. So,
Well, I have, not to your satisfaction, but I've answered them.
correct.
Yeah.
Correct. Okay.
I mean, I think it's, having you have such a deep-seated opinion that the approach that we are taking and I am pushing is the wrong one is not something we can deal with as a company. I mean, I can't have the director of marine ops not have confidence in the test plan or the construction of the vessel that he's in charge of. I mean, you can see it from my perspective. That just won't work. I'm not going to bend, you're not going to bend.
Yeah.
I mean, if I say it clearly,
Yeah.
I like you. I think you're a great pilot. I understand your position, but you have to understand my position and the approach that I'm taking.
Which I don't agree with.
I understand. No, and I appreciate your honesty on
And
it.
I'm the same. I like you and I respect you. We do have disagreements.
I understand.
A lot. But what I'm saying to you is, I don't want to see anything happen to you here.
Neither do
And
I.
What the heck, for the sake of paying some money and doing some research and get this thing checked out. Stockton.
We're not going to rehash this thing, okay?
Seriously.
It is not just paying some money and doing some research. I have looked into this ad nauseum, and I am confident with the acoustic monitoring system, which is what I brought back this whole thing to.
No,
You're
okay.
not, and I understand. But we can rehash this. We're two sides of this thing. We ain't getting any closer.
I mean, you just don't have any baseline of what's going on inside that carbon.
That's
You
damn
know
right.
baseline,
Damn
zero,
right.
nothing.
Yep.
Nothing.
Yeah.
We're
No,
on
no
the
doubt.
process for
Creating
developing a
baselines.
baseline, though.
Yeah.
That's what I've been saying this whole time.
I know,
We are
I know.
in research and development. We have to go down this path to establish a baseline.
But you don't know what's going on in there, Scott.
Exactly.
So
We
that's-
you
Yep.
have to
Doesn't
record the
make
data
sense.
and get performance reports to get
Right?
to collect that. Without going down a test path, you cannot collect the data. It's
But you
You
need
can
to
get-
know,
you-
you need to have a
It's
known,
the argument is about
a
what
known
the test
product.
path
That's
is.
the challenge,
to
and that's
get
with
your
carbon fiber. The only
baseline.
way to get a known product is to cut the thing up, and now you have non-destructive testing of carbon fiber is a real problem. And you want to go talk to Boeing, go talk to them, because I have spent a lot of time down there. This is a non-trivial problem. We took the other one down there, and even getting through 1 inch of carbon fiber is a problem. Nobody makes 5-inch thick carbon fiber pieces of this size for compressive loads.
Are we getting that baseline via, sea level, 10 feet, 100 feet? Is that, I mean, are we going
Yes.
to be taking those baselines
Every
over the
dive,
course of
every
the-
dive, we're going to have the data. We're going to generate almost a terabyte of data on a dive. And that's what we're having the statistical analysis done. How much can we pare that back? And then we're going to be able to compare. We're going to say, hey, something happened. What was that? And if we have an external transducer, which I want to have on there, we'll say, hey, that's a shrimp again. That's a ferry boat going over. That is a pop. It has a certain frequency. Let's mark it. Did we ever have a pop at 1,000 meters? No, we've never had one. Okay, we got a problem. Call it off. Cut the hull up. I got no problem to wasting money. I'm not going to die on this thing. But we're going to have this issue. We've got to figure out false positives. We'll figure that out here. It'll be interesting. We'll hear. I don't know if we're going to hear shrimp crackling. I don't know if we're going to hear whales farting. I don't know what we're going to hear through that hull. But it hears a lot.
Right. I guess.
And if you look at the pops we had in our testing, which was using the exact same system and doing it in parallel with Boeing system as a validator of it, you can see those pops, and they have a particular shape as opposed to just the background noise of the both electrical noise as well as the resin settling in. But even the Boeing people don't know what's going on. I mean, I've asked the experts at Boeing, what is that pop? And they said you can read 5 books and they'll give you 5 different reasons. It could be the matrix popping, it could be a fiber popping, it could be multiple fiber popping, it could be imploding, it could be exploding, it could be bending, it could be, they don't know. This is cutting edge stuff.
Well, I mean, I think
no question about that.
Scary.
Yeah. I'm much more scared about people getting hit by the dome, smashing their head, breaking their arm, crushing their shoulder, getting their hand cut off, getting their hand cut off in a prop because they got distracted, and that scares me a hell of a lot more than me dying in the sub, because I know that ain't happening. But I'm guaranteeing you, we're gonna have some major injuries. We're going to have somebody who's going to slip and fall. We're going to have, they had it when they did the Titanic. We're going to have people with collarbone injuries, with broken arms. We're going to have stuff. I want to make sure it's not because the dome ran away and smashed into them. I want to make sure it's not because we did something stupid, but it will happen.
Are we setting up safety procedures for topside? I mean, I'm assuming we are.
Yeah, and that's why we have two doctors on it. We have 2 full-time doctors and a hospital on staff. Yeah. So there will be stuff. That's where our risk is. Our risk is not in this, but
I'm going to come back to me being a CPA, and I've brought up items with you that are accounting related that I feel uncomfortable with, that you are taking the risk on to say,
And when you had the questions about the international transfer of funds between our subsidiary and us, I knew you were completely wrong, but you need to hear from somebody else. And so I said, you're completely wrong, but yes, go to your guy.
I wasn't completely wrong.
No, but he said, they don't care about, as long as it's a tax issue. I wasn't trying to avoid taxes. So I am open to this.
No, and I get that. But you did allow me to come back and do my own research.
Correct.
And realize that I was wrong. But I think that's where David is coming from. He's got a duty of care where he is sitting saying that here's my knowledge and here are the things that I see. I have to bring them up, or else
that's why I'm saying we're at this impasse, because I'm not going to get there, because we're coming from different sides of the problem. And I don't want to force him into being out there badgering the shit out of him, and he just knuckles under to say, yeah, I'll let him do it. And that is not the place. 1, I don't think I can do it, because I don't think I can badger him sufficiently. And 2, I don't want anybody there. I don't want anybody in this company who is uncomfortable with what we're doing. There are a lot of people out there who are excited about doing it. But I don't want to force people. We're doing weird shit here. And I am definitely out of the mold. There's no question. I'm doing things that are completely non-standard. And I'm sure the industry thinks I'm a fucking idiot. And I know Patrick Leahy's telling everybody we're stupid fools. That's fine. They've been doing that for 8 years. And I'm going to continue on the way I'm doing, but I'm not going to force people to join my religion if they don't want to.
I don't know. I mean, we are sort of at an impasse. I agree. However, I think we need to separate for a while. I don't think we need to make any decisions right this second. I think we need to, it's a Friday, let's sleep on it for a couple days and think about things. That's my opinion.
It may be your opinion. What I don't want is I don't want David to knuckle under.
I don't want him
Because
to do
I
that
don't,
either.
yeah. And I don't think in 3 days you're going to suddenly say, you know, Stockton's right.
No, I agree. I don't think that's going to happen. It may be that where I sit right now, I'm not comfortable with acoustic monitoring because I don't
Correct.
understand it.
Right.
But I'm willing to, under Tony's tutelage, learn more. Perhaps that is...
Learning's not going to be nearly as good as watching it on the sub. But yes.
Correct, yeah. I mean, and that's something that's going to have to be done as well. I don't know if that's something that David is comfortable with saying, okay.
But he's still not going to be comfortable with a live test. So, I keep going down this list. We have these fundamental disagreements. And if you knuckled under, I know it wouldn't be authentic, and I don't think you'd do it.
Well, instead of...
And I'm not knuckling under.
Instead of you talking for him,
Yeah, okay.
I guess and I don't want to talk for him either, but I'm going to play David's advocate here and just say, as opposed to because I feel like you're heading down the let's make a hard separation right now, let's just do it. I feel like he should be given the opportunity to think through this and say, is there any situation where I could be comfortable? Let me think through it instead of, making that decision right this second. I feel like, could you ever become okay with acoustic monitoring? Is that something that is that something that you could?
Absolutely, but we did not have a baseline. We don't have a baseline.
We do. We have one at 10 foot.
I'm just concerned. That's it. I am allowed to be concerned. You employed me for a reason, okay? I've been doing my job. This, for me, is health and safety. That's it. And I'm allowed to disagree with you, as we said.
Correct.
So I disagree with you.
Right.
I do disagree with Stockton.
Right, and that's what I'm saying. David is clear. We've known each other long enough. He doesn't knuckle under.
Well, I understand that, but there are
is
things
there-
that
is
you and
there-
I disagree about as well, that you've said, no, this isn't happening. I still disagree with you,
Right.
but I continue to work for you.
Yeah.
But are we at that type of situation,
this
or
is-
are we at a...
This is different. That's a...
Yeah, it's a payroll issue. Or
yeah.
I get it. We're at
What Bonnie's
completely
asking
different
is,
scales.
do you let me go? Do you now want to let me go? That's the question.
I don't see we have a choice.
I feel like we're being hasty.
Well, I think we've been very clear on what David wants to do to be comfortable and what he thinks we have to do this safely, and where I say we're going. And I don't see that there's going to be any bending on that. Because they're fundamental issues. It really is. This is it's a Buddhist and a Christian thing or something. I don't know what it is, but this is who he is. That's why we hired him. It is for that level of detail and safety and approach to it was the primary attraction to bringing David on board. And now we've gotten to a point where his experience and his estimation of the correct way to go is fundamentally opposite of the approach that I want to take.
What were you saying, Scott?
Yeah, to me, this is, I keep on saying the same thing. We're on this path, and to me, like in my path at Oceangate, we're on this trail collecting these performance points and then making rational decisions along those points.
But that's not an approach that David has been involved with. It's not an approach that is an industry standard approach. It's not an accepted approach with the way the industry works.
I'm wondering if that is acceptable as a cure.
What do you mean?
Is there ever a path, or that's something that David's willing to do and go down that path and collect that? Because I feel like we've done that path on the Lars.
People aren't into Lars.
With David, and That's just my comment.
Are you like for lack of a better word, like a make it up as you go along? I mean, is that?
Well, that's really.
I know that's what this is, and
This is a research and development program, and it eventually will transfer into an operational procedure and an ops deal. But we're going to collect data points that are going to set limitations on the eventual operational procedures. That's reality of this program.
right.
And so there's a lot of undetermined facts right now that we don't know, that we can't say. We know that, you know, the hull is good to whatever, or what.
Yeah.
We don't know all the information, and that's, to me, one of the attractions about being here at Oceangate, doing the innovative stuff, not knowing what's going to happen, and you know, and having that intellectual stimulation and
regrouping and, you know.
and tackling, you know, sophisticated problem solving. You know, I think that we've gone down that path with the LARS program. I'm looking forward to that path on the Cyclops 2 program, and to me that's an attraction. And I just feel that, you know, that's just for me. But everyone's got to digest this their own way and be comfortable with it, like we've said. Either you're not comfortable with it or you are. I'm comfortable with it.
I guess the question is there anything, I mean, going down the same, I guess what you're saying, like the LARS path, doing it, you know, the Titan path.
Yeah.
Is that something that you could ever be comfortable with? I mean, that.
Yeah. I just feel a tad let down right now with your comments. I'm pretty gutted, to be honest with you. This is the first time on paper I've ever put any health and safety concerns, and by God, Stockton, you know, on every expedition we've had issues. And I've been there for you.
Yep.
Every single expedition.
I'm not denying that.
Everyone.
I'm not denying it.
Yeah.
But show what is the path forward, given where what your opinion is and your experience is telling you,
Yeah.
and given what I've told you where I am, I don't see how that path moves forward. That's the issue.
We disagree on that path. That's what it is. It's a disagreement on the path. On how this should be done.
And a disagreement, in my opinion, isn't something that necessarily means that we need to part ways. I mean, it may come to that at some point if we get to that point, but I don't think that right now the answer is to part ways. I'm not sure that's the right answer.
Well, do you see a scenario where you will be comfortable with me being in the sub for a live test of this hull?
Right now, no.
Under what scenario would you be comfortable with that?
Get the hull scanned.
Okay, so unless the hull's scanned, you wouldn't, you will not, there's no way you'll be comfortable with me doing a live dive, regardless of what acoustic monitoring does at 1,000 meters and 2,000 and 3,000.
The acoustic monitoring will tell you what is happening.
Correct.
Not what is there.
I understand. And I care what's happening.
That's my concern.
Okay, so
You don't know what is there.
unless the hull is scanned, you will not be comfortable with me being in the sub for the depth trials.
Correct.
That's correct. And there's nothing that's going to, no amount of acoustic data, no amount of going out and towing it and driving it around here or taking it down is going to make you comfortable.
It's very different from you putting yourself in that hot seat and taking it down there, and we don't know. There's no baseline. That's where I'm going. There is no
Yes, there is.
baseline on that.
Yes, there is. There's a baseline right now. I got acoustic data right now when it's sitting there. I'm going to have acoustic data at 10 feet. I'm going to have acoustic data at 20 feet. That is a baseline.
Yeah, can we create that baseline?
You don't know what's in the matrix. Yeah, that's right. You don't know.
We don't know.
That's exactly. You don't know what's in the matrix. You don't know if somebody from Spencer Composites took a ham sandwich and threw it in there in the middle of the night.
Correct.
You don't know. You don't know if 50 mosquitoes came through and they had a locust swarm and it's all in the resin and you got tons of voids.
Correct.
You don't know.
DLAMs.
That's correct. And that's why we have acoustic monitoring. But you're not going to ever be comfortable with that alone unless the hull is scanned and you know what it looks like. You've said you're not going to be comfortable.
The company has deviated from that original plan.
I understand.
Doing it.
Yeah.
We have.
Yeah, we've deviated from a lot of plans. We've deviated from a whole ton of plans. Yeah, I was going to have Boeing build this. I was going to have ATK build this. I was going to have General Dynamics build this. Spencer was not my first choice. TIFAB wasn't my first choice. We've had to bob and weave and catch up and do a whole bunch of shit.
I still don't want. I still don't want to make a hard decision today.
I think Stockton's made a decision.
I don't see how I can make any other decision, unless and I don't want you to cave to placate me. I don't think you'd do that, and I don't think we're going to have a meeting of the minds. And this is a critical thing. If you're going to be director of Marine Ops and you're not confident with the approach I'm taking, that can't hold.
All management disagrees on something at one time or another. You know that.
Yeah, but this is more than a disagreement. You're not going to stand by and be sitting on the deck while I go down there.
Unless
it's done the way you want. I mean, we can wait till Monday, but I don't see. We keep bouncing back to the same spot.
I'm not going to change my mind.
I know that.
You know that.
Yeah, I know that.
You're not going to change your mind.
Exactly, I know that too.
All right then.
And I don't, I appreciate this huge sacrifice you've made to move out here. I appreciate you've been a hell of a great employee. And I think you're a great pilot. And I'd love to be able to have you do stuff with us. But this is the future of the company. We're going to find something for Antipodes. We're going to find stuff for Cyclops 1. But this is the future.
If we go down this path, we get this performance data, we do execute on our plan. David, would you ever be comfortable, given that we have this impasse on this baseline with the Cyclops 2 program?
The Cyclops 2 program, excited, and I'm going to swear, and I know we should, the shit out of me, okay?
Mm-hmm.
From day dot, I've been involved with it, okay? The whole APL thing, moving on when Tony came in, fantastic, excites me, okay? Yeah. I'm just bringing up safety concerns.
Yeah.
That's it.
But
that's it, that we disagree on.
Yeah.
Scott, the main thing here is, Stockton and I are not going to agree on this.
I understand that.
That's it. What happens in the future, when you're doing your testing and stuff like that, then that's different. That's out with of what we're saying just now.
Yeah. I'm asking you if we prove that what we have given right now down this path of performance review, if we prove this program, is that something that you will ever be at some point comfortable with, given the future data that we're going to collect? I mean, we are going to collect this data. We are going to get these performance reports.
But if you don't, but David's point would be, if you don't know what's in the matrix, how do you know on the 6th dive, the 60th dive, the 100th dive, the 101st dive, it's going to fail? Yeah. And unless you have confidence in the acoustic monitoring, his concern is legitimate. It's the orthodoxy. It's what people would say. You did 100 dives to the Titanic, on the 101st it's going to implode. I don't believe it. And you do, and that's the impasse. So he's never going to get comfortable.
But a lot of people thought that Carl Stanley was going to kill a lot of people. And now people are like awarding him things like, oh wow, he's like, one of the most experienced pilots in the world,
He's still dangerous. But he's dangerous for a different reason. He's not dangerous because of his engineering, it's because of his ops.
Yeah, but
Yeah, but
you know what I mean? He's got more respect, is what I'm saying.
What I think Scott is trying to say, I think,
Yeah.
is we're at an impasse, but
Is there a
we
cure?
need David on this crew. In my opinion, we need him here.
He has to, yeah.
Stockton
He has to be comfortable with it.
exactly this now, yeah.
Well, we don't need any, quite frankly, everyone is replaceable. It will be a huge loss to lose him. We'll have to recover through it. Because I can't have him questioning everything, the process. You're going to be highly uncomfortable if we continue down this path to the level of it's not appropriate for me to put you in that position. For me to go do stuff that you think is insane, that I'm going to kill myself with a vehicle that hasn't been checked out to the way you want. And I'm going to try somehow have him be associated with that and overlook it, which he won't do. That. Yeah, we need somebody. This is a huge loss. He's a backbone of this company. He's worked his ass off on it. You've been on every expedition. You know the shit hook, line, and sinker. This is not like idiot face, Coast Guard schmuck. He's core. But this is also a core problem.
I agree with you.
Yeah.
I agree with you.
I'm not trying to be an asshole. I'm not trying to be an asshole.
Stockton, please
Okay?
understand.
Yeah.
I'm not saying you're going to die. There is a risk that it could happen. There's a risk any time we put activities in the water, any vehicle. I'm aware of that more than anybody here. Okay, and I know your flight experience and stuff like that. I've done a lot of dives that went wrong. Okay, so I understand and I still do it. Okay, but the feel-good factor is in there, and the feel-good factor is not going to be fulfilled by you to make me comfortable to supervise you topside while you be down at 4,000 metres. That's not going to change. If we knew the hull integrity was intact, absolutely, not a problem.
Well, I do know that, but you don't believe what I believe.
Yeah.
That's the issue.
That's the issue.
There's a
Yep.
we've all experienced it, all of us. That gentleman that was sitting there earlier on, Tony, he doesn't bring confidence to the table. Not for us, Scott. I'm not. Bonnie, it just none. He never has. Okay, you know that with Cyclops too. Fortunately, he's stayed out of the way of Antipodes, and she's performed every time. Yes, I am running a no vote of confidence for him. So,
Yeah, and that's also a huge problem. I mean, the fact is, I take what he says, I take all the other information sources that I have, and I distill them, and I have confidence.
I mean, Scott and I have both seen so many schoolboy errors on fundamental components that's going on to that new vehicle.
Okay.
And you would be taken aback. You really would. Schoolboy errors. And it's a lack of experience. He may be a materials engineer, but he has not got the experience for submersibles. End of. This is his first build. This is going to be one of the most trying projects, and it really is. It's innovative, I don't doubt any of that. But at the end of the day, he brings no experience to the table.
Okay.
He is learning as he's going. That's it. So.
Nothing left.
At will state.
What?
At will state. No nanny state here, eh? Okay. No. Done. Done. Okay. Whew. Okay. I've got to say my goodbyes. Yeah.
Some are easier than others.